So we'll have the recording started. I'll go ahead and share the screen here. Make sure everybody can see that okay. And I'm going to turn off all the video feeds. Just to save the bandwidth. All right, everybody can see the screen okay? So, yes, where we finished up was talking about some points and point groups and some of the different things you can do with those. And the concept of Carlson using similar commands to drawing certain geometry, but with the one notable big addition that anytime that AutoCAD would normally prompt you for a point, at which point you could click the mouse or type in a coordinate value, which you can always still do that with the Carlson command, but you can also use coordinate point numbers. And also, by the way, in case anybody's wondering and hasn't done it yet, you can also use letters in your point number designation. It doesn't have to be numeric. In fact, a lot of times, and some of you folks that are experienced with field to finish, sometimes maybe you've got a couple of shots along a feature, for instance, and it's like maybe point number 137, go to point number 138, but you realize you should have gotten something in between in the middle. Well, since field to finish typically connects things in point order, if you go back and obtain that shot in between that you need to insert it in between, you could make those extra points like 137A, 137B, 137C, and then 138. And so it will, behave accordingly as if you had shot that. You don't have to renumber all your points. So keep that part in mind if you ever find the need to do that. All right. So we're going to talk a little bit now about, we talked about the points and such. I want to talk about these, the concept of terrain modeling. Now, I'm sure a lot of you guys have done this kind of stuff. You've generated your contour maps and things from your data, but we want to make sure that we have a really deep understanding of what's going on when we triangulate data. And if we look at page 8, starting to page 18, there is, it's physical page 24, but numbered page 18 in the book. There's a, let's see, there's 2, 3, 4, 5, 6, 7, let's call it 7.5, almost 8 pages that discuss all of the mechanics about what's going on and how terrain modeling works and what our job is to, when we collect our information out in the field, how we're going to use that to build a terrain model, which most of the time in our case being a surveying function, is we're trying to represent the existing ground, what's out there on the ground to use as a base for designing or something else that, somebody else down the line can work on our work and use that as a model. And of course, in the old days, we would hand over some paper maps that had drawn contours on them, a couple of spot elevations shown, and that's really all they got. But the advantage now is that we can get delivered to somebody an actual surface model, which contains information about the ground in between those contour lines and those spot elevations. And it's basically, if the only thing we had, if the only thing we had done to create our model was to read a set of drawn contours, then all the ground in between each contour line would simply be a straight line interpolation between those contours. But that's not what we're going to deliver when we deliver a surface model now, is that we are going to have little dips and rises and things like that that may not be big enough to trigger a contour drawn, but they're still part of a surface. Like you might have a little 6-inch drop off on a curb that you wouldn't necessarily notice if you're doing 10-foot contours up at a 200 scale map. But when you get down into the design scale at 1 to 20, then you're going to see things like that. You would at least see the contours wrap up. It would hit the face of curb down the gutter, climb up to the top of it, and then go across the top. And that crossing spot would be about halfway between the contours down in the street level, and they come out of the back of the curb halfway in between and go out the back. So we need to be able to model those edges out there in the real world and bring them in as part of our model. I've worked, and not that long ago, I worked with a engineering company that the designers didn't really deal with a lot of that stuff. They would draw contours across a parking lot, and go from the ground on either side, crossing the curbs and through the parking lot, cross the next curb on the other side and back out without any change in it. And their response to, my question at the time, what are you doing? Why aren't you indicating the rise on the curb? And their response was, well, the contractor knows what we mean. And there's just no reason to do that. There's no particular benefit in doing something halfway when it's just as easy now to do it the right way and to do it fully. So what we're going to talk about here, and then get our fingers dirty, playing around with some data, is how we can model that surface the most correctly that we do. Now, those of you with some experience in this is probably some review that you already are aware of, but the basics behind what we're doing here when we model a surface is we're building a network of triangles. If you see this figure 1 down there on page 19, is that we have some point data with elevation on it. And those can be anything. They can be Carlson points. They can just be vertices in 3-dimensional polylines. They can be, vertices in 2-dimensional polylines that are drawn at those specific non-zero elevations. It doesn't matter. Any time it finds either an AutoCAD point, which is contained in a Carlson point, or a vertex in any of our data, it's going to look at that. If we select it and tell it to triangulate this data, it's going to look at all those points and start to build a network of triangles. And they are irregularly shaped, which is where the term comes from, a triangulated irregular network, or a TIN. And the reason we use triangles is because it takes 3 points at a minimum to represent a piece of a planar surface. So that is the smallest figure that we can use to represent part of our model. And we just stitch them all together edge to edge, and that becomes our overall total model. Now, the one rule that we need to remember, and this is where field to finish really comes into play for us, is that if we need to prevent a triangle edge from forming in a particular direction, we need to put a barrier between the start and stop point that we're trying to prevent. And here's an example. If you look at this figure here, figure 1, these 4 points, and look at their elevations, 100 on the upper left, 110 on the upper right, 100 lower right, 110 lower left. That could be, and the way it is depicted here, that piece of ground shows a ridge line going from elevation 110 across to 110, and it falls off to the left and to the right down to 100. Now compare that to the same figure, but if the triangle's formed this way, you would be looking at a line across the bottom of a valley, 100 to 100, and it rises on the left and the right to 110. The very same 4 points. And if we don't tell it which way to behave, the computer will model that the way the computer will find it out. And it follows a set of rules. And it's, can be rather complex set of rules. It's based on what's called Delaunay's criterion, where it says, like, when you look at a point and you consider all of the points around that point to form a triangle, it tries to do so with certain rules that it in places mathematically, algorithmically on those triangle formulations. Things like the centroid of the triangle is at a evenly spaced as it can be from the centroids of the adjacent triangles. So, there's certain rules that it will follow that will make it go, say, from this 100 over to 100, or conversely, like we saw in the previous page, from the 110 to 110. Sorry, this thing's jumping on me. So, and in this particular case, it's often, to our understanding, it's just random how it happens. But if that feature is actually, in fact, a ridge line like you're seeing there across the 110 elevation, then we have to create in our data, before we triangulate it, a barrier so that the points on either side of that barrier are not able to look across the barrier and see the other points. In other words, if we draw in this line representing that ridge line across the 110 elevation, and then we start to triangulate, if we're sitting on this upper left point at 100, it looks around and all around itself, and it tries to make triangles. It sees this 110, it can make that one, so it goes ahead and does it. It can see the other 110, it does the same thing. But it can't see this point 100 over here because it's on the other side of this wall. That's what keeps that triangulation from forming in this other direction. 100 to 100 can't happen if we draw that in there. And that's what we call a break line. And I'll give you my little rule of thumb here on these break lines, is that when I was first learning about break lines and terrain modeling years ago, the definition that we got was that, a break line is a break in grade. Well, okay. And I can see that if you're talking about, let's say you're out here on the ground and you're down here at this 100 and you're walking over toward this other 100 elevation point, when you get up here to the top of this ridge, the grade's going to break and you're going to fall down here to the 100. So that's what it meant by the term break line. But I always thought about it in this direction instead of transverse to it. I always thought about it as walking along the feature. So I never really understood the term break line, because to me, from 110 to 110, the grade didn't break anywhere. And that was just my misunderstanding. But then I finally realized that, regardless of what you call these things, the thing to keep in mind, and the rule that we want to use when we're doing this, is right here. These are nothing more than edges. So if we have something that is a defined edge on the ground, even if it's poorly defined, like it might be grass, but it might be concrete. But right here's this little tip that if it's an edge out there on the ground, then we need to make that an edge in our data set. Now, a practical example of that is right here with this curb structure, okay? If we were to survey these points, A, B, C, D, E, F, G, H, and not put any break lines in, it is entirely possible for these triangles to form the way you see them here. So A can connect to B, which is valid. A can connect to C, which is valid. B to C is valid. But A can also look up here and see E and decide that, okay, I'm going to connect and make a triangle edge there, but it doesn't happen that way. It needs to go down to the face of the curb and then up to E. So A needs to not be able to see point E. Same thing, C to G, B to F, D to H, same kind of limitations there. Now, what some people have done and what some people continue to do is when they're out there surveying, because, really surveying is sort of cheap on a per point basis. It doesn't really cost us a lot to get a point. And so a lot of people would go out here and they get points back here. They come up and shoot the back of curb, shoot the top of curb, shoot the face of curb, shoot the gutter, come out here and shoot the center line. And then they walk like 50 feet down the line and repeat that, sort of like taking cross section to cross that structure. Okay. And that would generally work most of the time because this cluster of points will tend to form those triangles nearby before it forms them lengthwise down the structure. So that a lot of times managed to work without causing problems, but sometimes it didn't. And sometimes you would get these little diagonals that aren't valid. So we have to actually draw into our drawing before we do the triangulation, the line that represents that break, that edge. So I would need to create a line that goes through G and H, another one that goes through E and F, another one that goes through C and D, and then finally another one from A and B, then also through the center line and on the other side of the road. So with those 3D lines created through those points, I then triangulate all of that data, and now point A can no longer see point E because it has this break line in the way. And that does a number of things for us that would wind up, forcing, you can see the proper triangles over here would form in that fashion. So one of the things that does for us as well is that keeps us from having to go out there and shoot a bunch of points here, go 50 feet down, shoot a bunch of points here, go another 50 feet and a bunch of points here. If that's all one big linear feature, 500 feet long, we really only need the points along the ends of them. Go 500 feet away if you want and get the other points. You don't need the points in between because the computer can interpolate along those features and generate triangles that connect to those as if we shot all those points. Now, that does get into some iffy field work sometimes, particularly when we're trying to reflect the existing conditions, because it's never the case where you've got a 500-foot run of concrete that's all continuous without, with all one linear change or linear change in grade. So we do have to go and pick up all of the little, the places where it's no longer a linear change. So we'll pick up all of those things. And I'm sure you guys that do your work in the field are probably, second nature. That's second nature stuff to you as to what points you need to get. But when we start to use break lines, we can get away with having to get quite so many points as long as we're smart about what we're doing. And this is what we mentioned the start of yesterday. And I think, I forget, it was maybe Savannah, maybe it was you that was talking about, it was one of you anyway, that does some drafting work. Actually, it might have been Sally. You know, so as you draw up this base map and get things ready for people to work. And so when you think about that out in the field, if you're out there holding the data collector and the reflector or the rover, the GPS unit, to where you're measuring the points, if you think of yourself as drawing that map while you're out there walking the ground, then that's what you're going, you know, that's what you're striving to do, is to start building features by shooting a point and then deciding if that's part of a break line as well. And then you go on and get the next feature, and those points then become connected when we bring them back into the computer. And we don't have to sit there and spend 2 days playing connect the dots. It just comes in already connected. Okay, so hopefully that's pretty well understood, especially by you folks that do a lot of the field work. And so here's a couple of things. Let me make sure we don't have. Yeah, so here's a couple of things to consider then. Is, you know, remember, we have to put barriers in between points that are not supposed to be looking across to see other points and start to connect those triangles. But, you know, what are some of our sources of data? And we really, you know, we look at this, and again, you can even extend the thought model here, is that you can model any kind of surface, and it doesn't have to be, you know, we're always modeling ground elevations, but it can be anything. It can be population density, temperature variations, age distributions, anything like that. And but what we need is something that is spatially located in the horizontal plane, the X and Y, and also has a Z component. And that's what we're actually modeling, is that difference vertically. Okay. So some of those sources then is, you know, how do we build them? We've got some perhaps previous files, maybe from some other company or somebody who's done some work in the past. Sometimes we have text data called a, you know, often called a digital elevation model, which would look like this down here on the lower left. It's just a series of points, X, Y, and Z, or it could be northeast elevation, whatever. And they're typically regularly spaced. And you would see this a lot in photogrammetric applications, where you could get that, where the photogrammetry operator just goes by the machine, drives to the next grid point, and it takes a sample every, you know, 10 meters across the ground, and then compiles a, you know, a grid of all these points. Now, again, that doesn't get us the break line data, but that's often something that we can use. And from aerial photogrammetry, we also get the final CAD map from that process as well. Sometimes all we have are paper maps, or even digital maps, if there's nothing more to them than just drawn contours and spot elevations. Okay, but then what we're going to be mostly concerned about getting is the actual observation of those point locations. Okay, and so then here's a little note thing to take note about. You need to get in the habit, if you're not already, of evaluating that data before you use it to build your digital terrain model. Okay, and that doesn't mean hold off on doing it. Sometimes it's an iterative process. We build the model, we evaluate it, we go back and fix any problems that are occurring, then we reevaluate. We keep doing that process over and over again until we're very confident in our model. And once we do that, once we understand how that works and we are confident in our modeling, then we should feel confident in delivering that file either to the designers in our own company or to another company or to a contractor that's building something. He's maybe going to load that up into a piece of equipment that is driven by machine control. But you know, that it becomes problematic if we're not very sure of ourselves in what we're building. And I still see that quite a lot, even today. Not so much from the surveying community, more so from the civil engineers, believe it or not, because they don't really understand this process as thoroughly as they should. And they wind up getting, you know, maybe their design, you know, maybe they'll generate a set of drawn contours and that part looks good to them as far as a nice looking map. Maybe they'll turn their contour smoothing on, everything looks great. Well, they don't really, you know, and then a contractor says, okay, well, now give me that surface file so that I can build it with my machine control equipment. And the engineer balks at that idea and says, well, no, we're not going to do that. And of course, they hide behind the lawyers won't let us kind of thing, liability issue. And the truth of the matter is they're just not very sure of what they've done. The contour map looks okay, but they don't want people looking under the hood very closely. So one of my missions in what I do with this business of training this kind of work is to try to make sure people know how to, you know, use your eyes, look at this stuff. We're going to learn how to use the 3D viewer, look at stuff, how we're going to find any spikes, any holes, anything that are obviously wrong with our model and how we go about fixing that. Okay. And so, you know, here's a very simple rule as well. We talked about everything that we want to use as our source information, of course, has to be at the proper elevation. And the simplest way to do that is to look at it obliquely, look at it from a different perspective instead of straight down. As you can imagine, if you're looking at this map here that you're looking at some data, if you're looking at it just in plan view, it would look perfectly fine. It would look the same, you know, even like this. If I'm looking at it in plan view, these edges over here, which often happen, I'll get center lines of streams, edges of roadways and stuff, and this stuff will all be done as 2D polylines, and this stuff up here will be done as 3D polylines. Those are my break lines, but I need those edges. If I need to use these edges as break lines, I need to get them elevated here in Carlson. Now, Scott, I don't know how far back your land desktop days were, but in land desktop, we could use things like this over here in figure 9, even at 2D, and we called those proximity break lines. And we could tell the software, hey, this is the break line, go ahead and use it as a break line. And it would do that for us in memory. We did not have to elevate it. It took care of doing it. Carlson doesn't do that. Carlson simply looks at the elevation of everything we consider and uses that to build the network model. So if these are down here at 0, they're going to get ignored if we have the little ignore 0 switch on. If it's not, then it will build triangles down to that at the 0 elevation, which is not what we want. So we would find this error very quickly by spinning it up and looking at it in 3 dimensions. So we're going to learn how to do that. A couple of other tools and techniques that are going to help us spot some errors. Now, another key concept here is, or here's an example, for instance. Here's some triangles that were built. You can see all the data on the inside that look, you know, the triangles that are smallish and they look okay. What's happened is our data goes out to this part here and then turns north and runs up along these edges here. All of this information in between here is simply unknown, but yet it still built triangles out there because we did not have a break line running down the outside edge of that data. And when it all happens to be on the outside of our data, that would simply be our perimeter that we need to put around our data. And it uses that to trim off these long exterior triangles. And we'll get into that a little bit as we see some of those tools that build that for us. But one of the concepts that I just want to start to say is to, I'm a big proponent of when we look at a resulting build of a surface and we use our eyes and we look at it in 3D and we say, oh, okay, I see there's a problem there. Well, a lot of people have the philosophy of, okay, well, I built my triangles. Now I'm going to go and edit my triangles to change that surface. And while that will work, that certainly will allow you to do that. My way of thinking is it's so much easier in terms of maintaining your data is not to build the surface, have some bad triangles, fix the triangles, but go back and fix the data that caused the bad triangles to occur in the first place. Here's a prime example right here. I can see this happens. I know I need a break line around this edge of my data. So that would be the first thing I do is I would, throw this attempt away, put my border around it and rebuild it and let it build these triangles. Okay. But if I wanted to go through, I could go through and individually erase those triangles and save my new resulting surface, etc. But if you get in the habit of fixing the data instead of just fixing the triangles, then you're able to go back and rebuild those surfaces if you ever have to, and you've got the data corrected at that point. Otherwise, you have to go back and keep editing those triangles, go back and repeating that. Now, I say that you have to go back and repeat those triangular edits. The new version now, I think it happened in 21, but definitely in 2022, they now maintain the edit history on a surface. So if you do edit triangles, it now in the new version will maintain that history so you can reapply those edits even to later versions of the model. But again, to me, my way of thinking is fix the bad data. Don't just fix the triangles, because that way everything underneath it, if you ever need to use it for anything else, you now have it correct if you have done it. If you've corrected the bad data instead of just fixing the triangles, okay? So with that, we're going to take a look at this file called sample from T3 Global, and we're going to see all the little nuances and issues and problems that we can see from that file and how we're going to resolve them. So, and that will be when we get back to as far as the manual goes. That's this first exercise on page 25. And we're going to step through a lot of these things are the stepwise approach to everything that we're going to be doing, looking at our triangles, some 3D viewer stuff. We'll do a little quick profile. And we'll do all of that as part of just looking at that one file. Okay, so we're not going to necessarily go point by point by point that you see on each page here, but we will cover all of that information. But it's there if you ever want to repeat it, okay? And then we'll finish up with this little start to finish kind of workflow, okay? So with that, let's go back now to our data. And I've got to switch back. I was doing some work last night on one of my projects, so I'm going to reset my set my directory's in the right spot. All right, so I'm looking for this file called sample from T3 Global. And if you get this shape file, that's just affecting some line works, some line styles, I believe. I don't think, yeah, it's ACC land. I don't even have that. Just say cancel. You can show your proxy graphics because this came out of some other photogrammetric process. Now, we've opened this file, and we also, because we opened an existing file, we look up at the top of our title bar, and we see we don't have a coordinate file open. Well, that's fine. We don't really need one. But what do I see in this file is a bunch of data, some of which are these points. You see those little, and they are AutoCAD points. They're not Carlson points, but they are points. And again, that's governed by the settings, AutoCAD settings, point style. If you wanted to, you could turn that on. Let me change the size up to. There we go. So there now, every one of those things is a point. Okay, if you wanted to see those points, don't really need to. So I'm going to put it back to those dots. Right. So that's some data that we have. What else do we have? We've got drawn contours and contour labels. And if I look at my inquiry menu, drawing inspector on and off, and I'll turn off layer name, but I'll turn on elevation. If I hover the mouse, I'll see that is truly at elevation 1315, 1314, 13, 16, etc. And if you hover over a point, you can see those individual point elevations as well. So I've got some contour information. I've got some points. What else do I have down here? Well, I've got things like this blue line, which might represent the edge of, I don't even know what it is. Let's see. It's on a layer called the site outline. So it's the outline of something. Or the outline of the cemetery area, this obscured area, maybe that's what it's outlining. I'm not sure. But it has an elevation of 0. So even though it's drawn in there, it's not going to give me any value. But I see all of these white lines. If I hover long enough over it, I should get that little layer pop up as well. Let me right click and show the layer name. And I'll see that's on a layer called VTopo BKLN. That's my break lines. Okay. So I've got some break lines. If I zoom in here and I look at this, the white lines are my break lines, but I've got these magenta lines. And that's on the road curb, but you see the elevation is 0. Okay, so that's the 2D versions of those 3D lines. And that's why now, in this particular case, this cycle. That polyline there, even though it's on this layer curve, and it is my 2D polyline, and this should be an arc, but because this was compiled photogrammetrically, the compilers just went through and dropped points down here. They didn't really compile that as a true arc shape. But if we were doing that in the field using field to finish, we'd probably come out here and set a PC code to tell it it's an arc, grab a point in the middle maybe, and then the PT. And we could, a point in the middle is not required as long as you've got an incoming tangent and an outgoing tangent, but it does require it to be tangent, that sort of thing. We'll get into that later in the field to finish. So, but in any case, we've got two things here. We've got the drawn planimetric features on layers like curb and road edge and such, but we have the corresponding break lines also showing. Now, knowing a little bit about the history of this file and where it came from and how it was used to generate the contour map that was delivered to the Pennsylvania Department of Transportation, I can tell you that the data was modeled by using all of these points that you saw, those little magenta colored points, and the white break lines. So those were the edges out there on the ground that the photogrammetrist compiled into the drawing, and then they gathered all of that stuff together and generated these contours. Okay. So that's what we're going to ultimately be using when we model our data. But for now, I'm going to right click and turn off my drawing inspector. For now, let's do a couple of things to help us look at our data. Remember, I told you that we need to evaluate the data. We need to look at it in 3 dimensions. We need to, we looked at a couple of layers, things like that. We need to see what's going on with their information to see what we can use to build this surface from. And one of the things we can do is just spin it up in 3D. Now I'm doing this by holding the shift key down on the keyboard and pressing and holding the wheel on the mouse and pressing it up. Okay, and let it go and it'll stay at that level. You can also, go and grab one of these corners on the view cube if you've got that turned on as well. So that's a real quick way of seeing, and you could look at that and see maybe if there was a long something drawn down here, you've got a problem with a piece of that data that you need to resolve. Okay, but once I do that and I have to set the view back and all that, well, that's really about all I can do with that technique is just kind of see it by eyeball. Well, Carlson has a corresponding tool under the view menu, show you where it is here in the 3D view. We have 2, now there's obviously more, but we've got 2 main components. We have a drawing viewer and we have a surface file viewer. And we're going to be using those pretty extensively here and learning all that it can give to us. They are also, notice the icons, there's the 3 colored cube. In fact, the name of the command is actually cube. And the surface file viewer is a related command. It actually uses the exact same viewer, but it gives you some different tools inside of it. You'll see that when we get into these. So those 2 icons, the 3 color cube and the what looks like a little stockpile, but it also looks like it's sitting on a computer screen. That means we're viewing the surface. So if you look at some of these other icons over here, for instance, there's that little stockpile, pyramid, whatever. It's surface related. That's where we build the surface model. It's triangulate and contour. Here's another one. You contour from the TIN file. So we take the model, generate the drone contours. So the 2 that we're going to be looking at are also on this surface menu. And it's right here, the 3D viewer window. And again, you see at the bottom there, the little help, and it says, allows you to view the selected faces, polylines, lines, and points in 3D, cube. Cube is the typed name of the command. If you wanted to type it, you can do so. And I'm going to skip over this other one. This is a flyover tool. It's also quite useful if you want to tour a surface. It sort of has almost like video game controls in that. I'll leave that to your entertainment at another point. But this surface file viewer is called cube_surface. All right, so those are the 2 we're going to be using a lot, and I'm going to grab them most often from this toolbar. Okay, and I'll tell you, and when I say that we're going to look at it in the 3D viewer, I'll tell you whether it's the drawing viewer or the surface viewer. And that's the only difference is to which data you load into it. If I use the drawing viewer, it prompts me to select information out of my drawing. If I choose the surface file viewer, it prompts me to choose a surface file that already exists. Okay. So let's take a look at our data. And that's going to go to our drawing viewer. The 3D cube was selected. It wants us to select our data. I'm going to draw a crossing window around everything. I'll conclude my selection by hitting enter, and it's going to pop into a viewer. Now, yours may be in a smaller window like this. It's resizable, repositionable. You can put it on the other screen if you have multiple monitors. Do anything you like with that, and it will retain that position and size to the next time you use it. All right, so a couple things you might immediately notice here is that the points actually show up nicely visible, because that's, Carlson is actually rendering those points large enough for you to notice them correctly so that you don't miss them like you saw back out in the main part of the drawing, out in here. And notice I'm still viewing that, but my mouse controls still work if I need to look at my drawing while still being in here. Okay. So a couple of other things that we notice about this. And we're looking at it, we come into it in plan view. I have up here in the top right-hand corner, I've got a control panel over here on the right-hand side, and it has 3 tabs across the top. Okay. The very first checkbox is to ignore 0. That's my default condition. If I uncheck that, you're going to see some things change, and then take the wheel on your mouse and zoom back out on it a little ways. And you can see what looks like, if I grab this arrow pointer and I point to this little blue cyan colored line, that's the edge of a road, So, and you can see the shape of that corresponds to the white lines up here. Now, the reason they're not directly stacked underneath it is because if I turn on this bounding box, see, this is what I'm actually looking at. And it is directly underneath it in terms of its data. But when I look at it in this viewer, it's always in a perspective mode. So even though it's down there at 0, it's far away, so it's showing it foreshortened. Okay, so that's, but we usually don't look at those things unless we're just trying to evaluate our data. So if I'm looking at my data here, I see all of that information. It looks, I'm still in plan view and everything looks fine, but let's look at it in 3 dimensions. How do we control that? Well, over here are our main controls. And I've got this business here in the, with this blue circle and this yellow square. You won't see much effect right now until we start to load up surface files and look at them as solids. But this is a light source, and you can see how it's changing the relative amount of light and shade. You can control, with the sliders for the brightness, the contrast, and the position. If you think of this as, you think of that yellow square as the sun in the sky, and the blue is the earth that you're looking down on it. So you're, out here on the edges, you're down at the equator. Right here in the middle, you're at the North Pole. So that's a way of positioning a light source to shine on your data. Okay. So again, you won't see much effect with just drawn line work and points. If we had drawn 3D faces, you could turn those on to show solid and you would see the shadows come into play. Now, these two zoom in and zoom out buttons, of course they work. There's a dynamic zoom mode and a zoom previous button. Those all work, but as well as this pan hand icon. Those all work just fine, but the wheel on your mouse also works just like it does in your CAD drawing. Press and hold the wheel and it pans. Roll the wheel in and out and it zooms. Now, the control that is going to position us where we're going to look at this in 3 dimensions is this second icon. Now, these icons are going to probably look different in your version.
Ken, what toolbar is this on? Like I missed the spot where you went into this command.
Viewer itself.
It's just viewer under the Carlson menu.
You're talking about how did I get into this viewer? Is that what you're asking? Yes, it's on the view menu, and it's under 3D view, and it's this drawing viewer. But
okay.
The toolbar that I took it from.
Yes.
Was I've got this surface toolbar out here, and you see right there is that same 3D viewer. It's that 3-colored cube. That's what and you're going to, as you start to learn to use this, you'll find yourself using it from that location. It's just a lot quicker than going view, 3D view, blah, 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 2 or 3 mouse clicks or drags and such. So just find it here, that 3D viewer. The other one is that surface file viewer, and on the toolbar, they're not next to each other, they're separated by the flyover tool. In the menu, they are next to each other. Okay. And again, it's the same viewer, but depending on which data you load into it is going to govern which tools you have available over here in the control panel. And they're all still mostly the same, but there's some slight differences. Okay. Now these icons, though, that you're going to see, I think your pan, forget what, does your pan icon look like a hand? The one that's to the left. I know this one, and they've really fixed the icons now in this version that are a little bit more descriptive of what they do. But you will see this second icon that looks like the old UCS icon, the old X and Y arrows, and it's got a round, almost like a rotation symbol, like an arrow that's curved that goes across the top. And what that's representing is that it allows you to control the position, not just X and Y, but also the rotational position of the view. Okay. So now here's how to work, and that's the main icon that we're going to use while we're in here most of the time, is we're going to use this to look around our site. So how we use that effectively, if you look down here, you see these axes lines. If any of them are locked, go ahead and unlock it. And then you can grab those, you see, and slide them, and you can notice what's happening is that it's just rolling it around those particular axes, right? And you can get, if you get all out of whack, this button in the far right bottom resets it to a plan view. Okay, and does a zoom extents. Now, with that being the case, go ahead and leave those all unchecked. And make sure you have this icon that's the X, Y, and the rotation icon. And then take your mouse over here and hover over the data area. And you see that the icon looks like an X and a Y with little lines on them, meaning that if you click the mouse, hold the mouse button down and move it left and right or up and down, see, it will let you reposition it in that fashion. If you then let the mouse up and then go take the mouse and take it down to the edges off the data somewhere until it changes into a Z with a rotation arrow on it. And it's not exact, okay? It's not like it immediately knows where the data is. It's just sort of, it gets off the data. And once it changes, click and hold the mouse and move it, left and right or what around. But the only motion that's going to do is around the Z axis. Okay, so that's how that works. You can let the mouse up, reposition it, move it around like this. Now, that's all well and good, but it sort of mimics the 3D orbit command in AutoCAD. But there's a little trick here. Let's go back and put it back to plan view. And the little trick is this. If you go back to plan view, but then if you go down here to this rotation axis, click the lock button on the Y axis. Okay. And that way, now if I move the mouse cursor into the data and it's X and Y, and if I move up and down, you see I'm rolling around my X axis and you see the slider moving on the right. But if I move it back and forth, it's not spinning around the Y axis because it is locked, okay? And that's going to be able to work to our advantage for us to be able to figure out how to look in a particular location from any direction we want and sort of fine tune our viewpoints, okay? So take the cursor, move it over into the middle of the data up toward the top where it's an X and Y. And what I want you to think about is this. Pretend you're standing in your driveway and you're looking at this data as if it is your garage door. Okay, you're standing, your feet down here, your head up the top, and you're looking at your garage door. You want to raise up your garage door, and it's one of those solid doors. It doesn't have the hinges in it with the segments. It's just going to lay back all the way as like a solid unit. So I'm going to put the cursor down toward the bottom. Not so much it changes to the Z cursor, but keeping it here, I'm going to click and hold the mouse, and I'm going to push it up. And if I have to get another bite, I'll go back and grab another bite. But I want to lay it back at a fairly oblique angle, about like that, okay? Now, once I have that, I let the mouse up, and now I'm going to put the mouse down at the bottom only, not the sides or the top. And now I'm going to spin it around and line up with where I want to look at. Okay. Now, once I get, let's say I want to look at, let's find that. So just say I want to look at this little perch pond right here. So I'm going to line myself up, and then I'm going to just let the mouse up, and I'm going to position the mouse, and I'm going to use the wheel to zoom in and out. Now, if I need to change that perspective, I can still do it to a point, but if I'm in really tight, I don't really know where I'm going to go. All I'm going to do is roll the wheel back out, spin it back around, reposition this if I need to, come back over here, lay it the way I want it to be, and then I can now zoom in. So if I'm zooming in along those curb edges up here on that main street, I'll zoom back out, spin it back around, zoom into these curb edges. And you can pan and zoom with the mouse, okay? So that's the trick, is to keep that Y-axis locked and think about, the nature of what it is you're doing. You don't have to try to remember rotational angles. You just need to think about, you're standing in front of your garage door, you want to open it up, lay it back obliquely, spin it to where you want it, dial into where you want to look. Okay, and that's essentially it. That will all become pretty second nature to you after you've used this a few 100,000 times. Okay, so now these next icons, the one that looks like a fishing net with a couple of squares colored in, if you click that on and off, it has zero effect of what you're looking at now because you're not looking at any 3D faces. You're looking strictly at line work and points. Okay, so that will come into play when we're looking at a surface file. The next icon is a pointer icon, and what this does, it lets you pick information. Now, not with a single click, but if you double click, it reads what you've clicked and it tells you some information that's on layer B topo break line. I can change the layer. I can set it to 0 elevation if I want. I can add it to a selection. And if I wanted to select a couple of things, let's do that. I'm going to add that to a selection, and let's zoom in now. Over here, add that to the selection, and let's go ahead and grab that one. Add that to selection. Now, what that's doing is I've added that to a selection. Haven't really done anything with it in this viewer, but if I look over here and I say any command that I need to pick objects for, if I say, for instance, isolate, now isolate the objects, this is not, there we go. So if I say P, messed it up. All right, end object, isolation, okay. I thought I could do that with the viewer open. I think I'm going to have to exit the viewer. So if I zoom in and say, add that to a selection, add that to a selection, and let's just add this one to a selection. All right, so I've now added to a selection. I'll exit the viewer. And now it tells me right here that objects you selected can be accessed by using the previous selection option. So I could say any command, copy, isolate, whatever. So I'm going to copy the objects. It says select objects. If I type P for previous, why is it saying one found? Well, anyway, hopefully yours will work. That's a selection. Selection. So that's all I really need to be. Yeah. Looks like maybe they broke that one again. It works in IntelliCAD, but anyway, not all that useful, but that's what the intent is for that control. Now there's a couple of other things with that control. If I use that arrow, that pointer, I've got some clipping functions down here on the bottom. Now your version, I don't know if you've got all three of these or all four. There's near, far, top, and bottom. You can synchronize the top to the bottom and the fronts to the back. And that's just, it's not something that you can get a lot of use out of necessarily. If I clip near, for instance, and if I slide it over, it's really sensitive. I'm going to get to where it starts right in there. So see, I'm taking the things that are closest to me and clipping them away as I slide that slider. So I mean, it's very useful if you need to get something out of the way and you don't want to, figure out what layer they're on and freeze them and all that kind of stuff. But it goes top to bottom, and it goes or near to far, near being the closest to where you're looking at it, far being the furthest away. Top to bottom is truly elevation. So if I've rotated up like this, let me rotate like this, and now if I grab the pointer, and you have to use that pointer to be able to do this, near, notice it's going to start peeling off from me to the data far, takes it from the back toward me. If you synchronize, front and back, it should say near and far, but it doesn't. So if you synchronize that, they'll come from both directions. You see the slider. On both sides is working in conjunction. So now from the top, if I go top down, even though I'm rotated, top is no longer just near to my eye like it is in plan view. It takes it from the highest elevation toward the bottom. This is a really nice way to, once you've built a model or something, you've got maybe a large feature, you're not sure exactly what it is, you want to get it out of the way. For instance, I can trim off, say everything but that pond area, just to help you verify and visualize that you've done things correctly. Go back to plan view. And now, the next business on these tools, you have some, you can pull this down, choose plan view, or if you want to look at it from the northeast, which would be up here, and it's a perspective view, or from the southwest, again, looking back there, or from due south. Okay, so that works with that. And you could say custom, and if you do say, well, let's do one like this. And if I choose custom, it's not. There, let's see. What to do. Instead of custom, let's see, let's go back to this. All right, so if I want to look at this view, say along that channel, going into that pond. All right. If I go to my settings tab, it might be in a different, it might be on the front page of yours, but it has a place called saved view. I might call that pond channel. Save that now. That gives me a view there called pond channel. If I go back to here and I make another, let's roll this back and we'll zoom in here and call this intersection. And so now that I have those views in my saved views, I can come here and choose intersection or pond channel set. So there I'm looking up that pond channel. So it's just saved that perspective. So if you got something you're constantly looking at, you can set that and don't have to reposition it. Now, one thing to be aware of, at least in the older versions, I haven't really tried this in other deals, but when I save that saved view, it's not just a position relative to whatever data you're looking at, it's a position in the world. So if I'm working on a job, 2 states away, and I pull this down and choose the view that I saved on another job, it positions me over in that same coordinate space over there. So it's It's not real useful, job to job to job. It's only going to be appropriate as you're working on a project. So if you're through with one, you may then come in here and decide to delete those if you're no longer using them. Okay. So now these buttons at the bottom, then, to conclude, you can save this as an image file with either 8-bit or 24-bit colors, and it tells you the approximate file size. Okay, and that's if it's a uncompressed bitmap, I believe. If I say okay, now notice what happens up here is my file that I'm going to save. Up here in the parentheses in the title block, it says JPEG, bitmap, portable network graphics, and a GIF format. All those formats are acceptable. All I have to do to change the formats is I would call that one, site.jpg would make it a JPEG. PNG would make it a portable network graphics. That's what these up here mean, but you just simply tag the extension that you want to create that type. Or if you hit the browse button, that's going to put you into the Windows file dialog, at which case now you have at the bottom this little pull down, save as type, JPEG, bitmap, PNG, GIF. Okay, so there is no pull down for file type in the Carlson dialogues. You just, when you see these up here, that's the acceptable extensions. If you type one, it will force it to that format. If you don't, it will create the default that it's set to create. And I think this one by default saves JPEGs. I'm not sure, but anyway, that's there. But it's useful if you get something, spun up here and you've got a, you're going to say, hey, Bob, you surveyed this out in the field, but it looks like it's got an elevation bust or something. Can you resolve that for me when you come back in next? And you can send that to somebody in an email and just as an image, and they can look at it. Of course, save it as a help system there, and then the door means you're going to exit the viewer, the same as if you clicked on the X at the top. Okay. Now, when we use the pointer, again, we've got this, if we double click, we can change layer, set it to 0, add to selection, although that part doesn't seem to be working correctly in the AutoCAD version here. But if you also look without clicking, if I look down at the status bar at the bottom, as I hover the mouse, that works a lot like the drawing inspector. Okay, so if I look at, say, this piece here along this polyline, it tells me that that is a polyline. It's on a layer D-topo break line. It's got an elevation range from 1299.39 to 1312.56. Well, 13 feet. Well, I guess it goes for a long ways. It's 248.10 feet. And that's the entire polyline range, all the way down its length. Okay. So again, this icon here is the one we're going to use mostly to control their position. And it's that one, they're going to use that one quite a lot, but these others will come into play. Now, there's a couple of other things that you can do. You can, set up some pretty fancy lighting. You can choose sky, clouds with water. Again, my rendering, because I'm going through an emulator, it's not really effective. But you can see these different things, and it might be something that you want to do, and it just helps you to keep. Let's see. Have to restart the command. All right, let's see if it did it. Back to tropical. So there you can see. You know, it's really, you know, it's sort of, it's more gimmicky to me than anything else, but it could help you keep track of, you know, where you are vertically. Like if you're spun upside down, you don't necessarily want to you know, that can help orient you because the clouds, of course, are up in the air. Now, the last bit here is this is a vertical scale. This is a vertical exaggeration or flattening. So if you want to look at something, your terrain, your job site is mostly flat, put it like a 3, 4, or 5 time vertical exaggeration. And now you can really start to see the relief. And that does so without changing the data, of course. It's not changed one bit of the data. I can unlock that. There we go. All it's doing is exaggerating that so they stand out. Okay. Now, that will stick between sessions. So make sure you put it back if you want to put it back. You can also flatten it if it's too steep, you know, but that our site's fairly full. Okay. And then the last bit is this color by elevation. Right now it says none, and you can set it to all or surface only, and that's where you see this business here. This is that color by elevation. Now this is looking at the surface after we built the surface. It can also work on the data itself, on the line work. You just won't notice it as much. So if I say all, there you can see the data by color. Okay, and those colors are set on the settings. Set your colors, you can set, you know, high, middle, and low elevations, etc. You know, what this is useful for, and you know, one of the things that I really don't care for this, a lot of the Carlson demos on YouTube, for instance, when they show you how to do a lot of stuff when they're looking at the surface data, almost all of the sales guys that make those demos, they leave that switch on. So they're always looking at color, elevation by color. I guess they think it looks cool. But there are other instances, particularly if you do a lot of road design, where you can actually have like the pavement become, you know, you can set it to be gray, the concrete to be real light gray. You can have the grass is green, you know, cut banks, fill banks, ditch lining, all those different things. So that, you know, and then when you view those triangles, they have that color information built into the triangles, and you'll see their real colors if you don't have that switch on. If you do, it colors it based on elevation. There's nothing wrong with that. You can leave it on like that if that's something that suits you. But I like to see what the true colors are unless I have a specific reason not to, or a specific reason to do this particular view. And here's what I'll tell you about this view. And then we're going to take our break here. We're about 5 minutes past it. But this is a really good QA/QC tool for your data if you're looking at stuff to, even before you, the first time you go to build a surface. If you view that and you just simply, you know, you can, oops, sorry, wrong one. If I say none, if I say then all, this will give you an indication of some potential busts in your data. So what you want to do is look over here on the scale on the side and see if the numbers look reasonable about from what your site is. You know, so I'm looking at this, it ranges from 1283 to 1347. Now you can't set the scale, it just figures out low to high and divides it up and shows it to you. But if you're looking at, and you see the color, so if you're looking at, say, you know, a spot over here that's like bright red and then everything else is blue, and you see this number up here goes up to something like 50,000, and then these other numbers are down where the site is, well, that tells you immediately, and you can see immediately the area that has some problems. Okay, so it's a good QA/QC tool. So one thing we want to look at is to make sure that you've got a fairly even distribution. Now, that won't always be the case, but you know, you're going to know your site. You would expect it to have fairly even distribution of high places, middle ground, and low places. And in this case, my blues are my lows. There's my stream channel, my pond. This is the low part of my roadway. So that, to me, at a visual glance, tells me that things are okay. And also looking at my numbers, things are okay with my elevation. Okay. So if I had something, go ahead and exit. I would turn this back off. I'll exit this and show you what I mean by that. If I've got, say, don't want the building. I'll take that one. And let's suppose that was done at, I set its elevation to 2,500. I'm going to type cube, select all my data. Now, look what happens. I look at it in plain view. Well, the perspective caused that to jump out at me, but if I wasn't aware of that, if I turn on my color, you see how there's only one thing that's red, but everything else relative to the overall total is blue. And I look at these numbers, 2,500 is just way too tall. I know that's outside of my site. It's supposed to be, you know, something else. All right, so well, not let me pick it, but in any case, you can see I can use that as a QA/QC tool to help me figure that out just visually. Okay. I can also, again, when I see this and start to roll it up, well, that tells me immediately I've got a problem. Okay. I can also, if I turned on my bounding box, if I can find where it is, here it is. I can see, you know, all my data is sort of clustered down here. And then even if, let's say I had 0 on, see, I've got zeros, I've got my data, I've got that item. Okay, so use those techniques to help you evaluate your raw data to see if there's any problems. You can see it immediately. You could tell if there's a bad point or a spike in the data or some such like that. The other thing is, if you need to, let's say no zeros, and let's say I rolled it around and I got it to a position that, oh, okay, I see something I need to change, I need to fix. That's a good view for me. But I want to do that back in my CAD session. So again, on my settings tab now, I've got this button to set the CAD view to that viewpoint. So I click that, it's now set, I say okay, and I'll exit, and there I am. So now I can address what I need to address. Maybe in 3D, it's easier for me to see the grips and do some edits, in which case I'll put that now back down to 0. And then go back to plan view and go from there. Okay. So It's about 5 till, so let's come back at 10 after and we'll take a break. Anybody have any questions so far on this?
Yeah. So when I have it in that color,
Yes.
mine's just all red.
Okay.
How'd you get to, have the different like blue
Yes.
and red and green?
Okay. So if you're here and you have the color on, okay, you say yours is all red. So are you looking at yours right now?
Yeah.
Okay. What are your numbers? Are your numbers reasonable or do you have wonky numbers?
On the left.
Yes.
Yeah, they're reasonable. They look like yours.
Like 1280 up to 1350 or so, right?
Yeah. Yep.
Okay. So what it is, you need to set the colors. So on your settings tab,
Yep.
there's a button there that says set colors.
Yep.
Now, when you do that, you should get a dialog that looks something like that, where you set the high color, the middle, and the low. Are they set to different colors?
Yeah, they're set to 135. Contour is 2, edge is 7.
All right, so you've got like the 135, that should be red, green, and blue, right?
Yep.
And you're seeing that as red, green, and blue.
Yeah, on the side, but
In the dialogue,
yeah. Yep.
And okay, so when you say, okay, I've got something's sticking on mine. Here, I'll probably have to restart this. So, okay, get all that. All right, let me stop the share. Let me have you share your screen. Take a
Hey,
look.
Chris,
Yeah.
I had the same problem, but I closed it out and then went back into it and it changed itself to the colors that it was supposed to be.
Okay.
Oh, did it? Okay. Yeah, give it a try, Chris, and let me know.
Okay.
See if it,
Yeah, I got the same problem too, but on my left, my scale goes from 0 to 1300. So I think I just got 1 0 elevation point,
well,
but
look
like
over,
everything else is up high.
yeah, but look over on the control panel and see if you've got checked or unchecked the box that says ignore zeros.
Yeah, I got that ignore zero elevations box checked.
It is checked. So if it's still reading something down near zero, you've probably got something that's out of whack. And by the way, when I'm looking at this, I've been looking at the whole site. You don't necessarily have to. You just select data and it only loads up the data that you selected. So if you have your data selected, you're saying your numbers are down here at 0 and goes up to something at the top.
Yeah, that's correct.
And you have this ignore zero unchecked or checked, I mean.
Yep.
Okay. If you hover the mouse over well, can you tell? Let me see, the easiest thing I think is going to be let me have you share your screen and let me take a look at it.
Yep.
Okay. And I'll request remote control. You need to share the other screen.
Yep.
Okay, there we go. All right. So yours are all red and it's looking at plus 1347 up the top and it ranges down here to 0. So you've got one item. If I ignore, whoops, did I get let me request remote control. All right, so now, if I ignore 0, all right, so that's truly ignoring zeros. Let's do this. I'm going to go to settings. I'm going to turn on my bounding box. Okay, so in my version, the bounding box is down here. All right, so now that I've got my bounding box turned on, I'm going to come back here and now spin this up and see if I can find. There's something in here somewhere. Let's see if I turn my zeros on. Oh, unfortunately, you got something that's probably right at 0. Let's go back to plan view. Let's check that back off. So now if I look at this, I spin it up. See, I don't really see anything. I'm going to lock that y-axis. See, I don't see anything. So there's some kind of strayed data, and it might be, I mean, who knows? It's not like a point or a line, or there's something down there somewhere that's causing an issue. Now, here's how you can fix that. Unfortunately, we can't do this. We can't say, go to settings, set our CAD view like this, and then go back and try and fix it, because there's something down there somewhere that's close to 0, but is not exactly 0. Okay, I could go to my front view and see, if there's something. All of that stuff down there should be 0. You could do things like try to do a crossing selection, see if you can find it there. Try it this way, but there's another little trick I want to show you guys that's very, very helpful. And I told you about some of those tools that were helpful. And this is on our file menu. I mean, guess what the ribbon would be. Well, it should be under setup. I don't think it would be under draft. This is why I don't use the ribbon, because I can't necessarily figure out their intent. It is, all right, it's on the file tab. Anyway, it's this one called drawing cleanup. It's also on the file menu right here called drawing cleanup. And it does a number of items, and you can look at these at your leisure. There's a set of defaults that may or may not be what you need. You're going to clear everything. I'm going to show you this technique. One of the options that it will do is it will set things outside of a given range to 0 elevation. Okay, so whatever these numbers are, that's what it's going to find. Anything that is below -1,000 or above 20,000, it would set to 0. And that number, you can type that number in. So if you know your site is like, 1250 to 1325, you could type those numbers in. This little scan drawing button is handy. If you do that, you can see, okay, there's your drawing information. It's really like about 1280 to 1350. So if I type, say 1200 to 1400, that should work to fix something there. If I say okay, and of course it didn't find anything. Don't like that open. But that's one way that if you've got some stray data, you can maybe find it. If I do select this, and where was, must be here, Surface 3D viewer. Yeah, so I'm looking at that.
I was thinking maybe we could just instead of looking at all the points 3D, just select like the zero looking points and then look at that in 3D and maybe put a box on it and it'll pop up.
Yeah, the problem is I can't, I mean, you can do. All right, I think if we do this, for instance, if I go like this and look at that and crossing. Now you see they range from -0.9 up to 1. But I don't see anything. So there's some kind of stray data item. And there's all my zero stuff. Don't see my. Right, okay, so that is all about mid-level. Those are good. Let's see. Those are red, but that's just the color of the block, I think. Nope. Well, those are all good thoughts. That was a very excellent thought. I'm really at a loss as to what this would be. But if you ever get in a situation like that, and sometimes that will happen, that you've got some kind of strayed data, and it appears to be some kind of strange stray data. So a couple things you can do. As long as it's outside of where you're working, like if you've ever done a Zoom extents and it goes like way off the page and you can't find what that outside stuff is, here's a command under erase. If you erase outside, and you know that this is the extents of your data. Well, I guess I got to get big enough. So if that's the extension of your data, it's going to take everything that's outside of that. So if whatever we had was something that crossed our viewer, then that should have cleared it out. So I'm going to go back now and view that viewer and ignore zeros. Wow. There's something down. Can you read that bottom number? I can't really make out what that is. Is it? Looks like it's something small.
Yeah, 67.
Okay, so that means it's something that's close to zero, but we don't know what it is. Try this for a minute. I'm going to turn this off for now. Yeah, well, this is strange. There's something that it's finding, and it's selectable by a window. So the problem is I can't get into that near zero stuff to freeze. Let's see if I try this. Well, no, it still thinks when I do the drawing cleanup, it still thinks it starts at 12.99. So if I look at this dead on, everything. If I freeze. Turn that off for just a second. Now, let me try that. I've frozen a couple of things. Surface. And so it's not frozen yet. Let's see if I can just do that from here. All right, so now still.
Yeah, they're really going in on this.
Yeah,
Here's what.
you know, Travis did.
Huh.
So what Travis did is before he selected it in the 3D viewer,
Yeah.
he just flipped it.
Hmm.
And then he just selected the elevation stuff and left all the line.
The line work, yeah.
at zero.
This doesn't show any difference between the two. I don't think.
Yeah.
Yeah, it's definitely quite a little troublesome that he's like teaching us in a different software than we're using.
Yeah.
You know, it's 3 years later. It's almost like he should run his whole class screen sharing one of ours. So it's like
Yeah.
he's using the same shit we're using because it's like pretty tough to be
Oh, there you
kind
go.
of following along.
All
All right, so it's not on that layer.
I want to know something.
right. Running that through here.
Yeah. No, bro.
Yep. I went for a walk last night and I saw down by like some bait like around the dock and the lights.
Yep. Like, all right.
I wasn't bug light. It's just there's that dock that sticks out where the boats sometimes tie up to. Yeah. There's some lights.
Can't see.
Yeah, I mean, definitely was something. I don't know what it was, but
So let's take a look at these.
I got something out of- What's this right there? Yeah, remember it's like the current number
Ah.
is triple hump, so-
All right.
yeah, it's I should look that up too. I just found some books that I had at home. They were like,
Oh, it's on one of these layers here. So
yeah, I think it is. I think circle it too. It really sounds familiar. And then there's two eye sets. I would put the smaller one. You know, yeah. Yeah, that's what I'm gonna do. I think it's some rigs. No, it's for. Yeah. Yeah, and then just go out and jig mackerel on them. Yeah. Insane. And then- Let 'em- You're in it?
it's got something that's sitting there. But that's within our expected range.
Yeah, Travis came over and fixed mine.
And what happened?
So what he did is he got out of the viewer
Yeah,
and then he rotated everything so zero's down on the bottom and the elevations are up on top.
yeah.
And then he just windowed the top.
To view it, yeah, I know that's where the data is. So if I look at that data, well, well, let me put all the layers back. Yeah, so if I look at that data up there, so I know that all of this data is okay when I do the viewer. See there, that's a good distribution. That's what I'm expecting. Okay.
Yep.
So, but if I also do it as selecting this, see that range? There's something that's just slightly off of zero. That's all stuff that should be see, it's not showing up in my viewer.
Hmm.
So here's what we can do. is if I select all of this information, can you pull your properties box over to this screen? So what do we have in there? I've got lines, blocks, text, and polylines. All right. It's probably, possibly a block. All right, if I do this, I do a, oops. I change elevations, absolute, make it 0. If I select all of this, in fact, let me do a crossing. Now I know that they're all supposed to be 0. There's something that's not. Hopefully it fixed some of this. Let's see. Go back to plan. Everything's looked good there. Do my 3D viewer. No, see, there's something that's not quite. And it's on one of these layers. It's on either that layer or that layer or that layer, I think. So there's now everything there. If I view that, no, that part's good. That wasn't. Let's do that and that. Nope, that part's fine too. Ha, now it's gone. Let me see. If I turn on all layers. Select that into my viewer. Now this doesn't make any sense whatsoever. All right, so there's now it's showing up.
So what's going on?
So it looks like it may be here. If I view that, see that part's okay. That's the top part. If I view this, even that's okay. And these numbers over here are not absolute. That's, you know, they're all of that stuff is at 0. Because ignore it, it goes away. So if I select these two things individually, they're each okay. So if I do that, see, when they're in there together is when they have the problem. But if, and I'm doing these with crossing selections both times. So if I do that one and look at it, it's fine. Okay. If I do this one and look at it, it appears to be fine, but there's something about it. Try this. See, I don't see anything. All right, now let's look at this. See, there's something above and something below. Maybe, unless that's a vestige of the scaling.
I mean, maybe it could just be a glitch on my computer.
Well, yeah, but I don't want you to keep having that issue because we're gonna need to use it. Let's do this, and then let's remove from our selection set this, and I'm probably not going to fix it by doing this. Oh, maybe I did. Let's see. So I got rid of like 280 items. Let me see. Try it again. So crossing, so it found 527 items. And if I remove all of the zero data, it took 527 out. So that part stayed the same. Now, do you have, I think what I got rid of were those points. I can't see your dialogue. Go ahead and choose like the X's or pluses or something.
Yep.
Okay, so they're still there. I thought maybe I'd gotten rid of them. All right, so let's see if that did what we needed. No, wait, maybe. Nope. Well, I don't know. Let's go ahead. We're running way behind on your break here. Do me a favor. Go to, you guys are all in the same office, right? Or you're there with somebody who's also in the class?
Yep.
go to, then I'll stop
one
you
of us.
control. Yeah, go to somebody's whose works and just, you got a thumb drive or are you on a network that you can copy that file and bring it to yours?
Yep.
All right, give that a try and see, and we come back, we'll take a look at it. And if not, then there's just obviously some kind of a problem. So,
Sounds good.
all righty. So, oops, I got some chats here. Anything going on that I need to see? I can't see that. Let me come back to this and oh gosh, Travis is no longer mechanic froze to control, delete, open the drawing. Mine was all red, no two. I'm not in South Portland. All right. All right, so a couple people are not with us, Travis and Sally.
Can you,
Yeah, Sally, you're there. Okay. Did you just say that?
that was,
Oh, you have the same problem with the drawing. Okay.
well, my computer froze, so I got out of the drawing and reopened it and everything was all red like the one you were working on. But I'm up in Bridgeton by myself, so no one
Oh.
can help.
Well, we can just email you a new copy of the file. I'll send you that here in just a second. Travis, however, can somebody check with him, see if that link will
Yeah,
work?
he needs the link again. He can't get back in. I don't know if it's because we're recording right now.
Yeah, I don't think so. I will, I'm gonna pause the recording anyway. So everybody back okay? There we go. Got Mike, Jeff, Chris, Oscar. Colleen. Okay, well. Hang on another minute or so for Scott and Sally and Travis. There's Scott, okay. There's Travis. Okay, Sally, whenever you're,
I'm here.
okay, there we go. All right, we're all back now. So that's sort of some of the controls in the viewer. We're going to go through some of the others as we start to develop our surfaces and see how this is going to play out. So let's start working with our data and start making some surfaces to see some of the data problems that we can have and how to resolve those once we start to make those. So the first thing I like you to do, and I know that this is not the way we would do it optimally. Optimally, we would use the break line data, but for now, I want to turn the break line data off and show you what a lot of times happens for a lot of folks. So let's go to the view menu or your view tab and choose freeze layer by pick and click on one of those white lines that you see probably around the periphery would be easy enough to pick it without picking something else. Okay, now if we look at what we have left, I'm going to select it. And by the way, you may have noticed as you've used it, you know how AutoCAD can work equally in what they call noun verb and verb noun selection, where you can select entities and then issue a command, or you can issue a command and then select entities. Well, almost all of the Carlson commands are still issue the command first and then select the entities. And sometimes it's because of the nature of what it's doing. It's not that they haven't gotten around to implementing it yet. It's just the nature of the way they gather information and hand it over. So you'll probably need to, or you find yourself getting used to running the command and then selecting the data, and that's all still fine. But this particular command, this 3D viewer, the drawing viewer, it actually will work if you pre-select the data. Like I just drew a window around all my data, and now I'm going to go up and view the data. And I'm going to turn those things back off, and I look at what I've got here are a bunch of spot elevations and contour lines. Now, what happens in a lot of cases is a client will get, it's not usually surveyors that receive this, but a lot of times a client, whether it's a design engineer or what have you, they'll receive a contour map and they'll proceed to sit down and build a surface from the contours. And here's the data there. I've got one more data I'd like to, or one more layer I'd like to freeze. I'm going to go back to my point style and set those points on so that I can see them. So let's do that one more time. View, freeze layer, either by pick or by selection, either one, and just click on one of those points so that the points are now out. So now if I view my data in 3D, I have here nice little contour map, and these are nothing more than drawn polylines that the photogrammetry firm has provided for us. And so here's what a lot of times happens. Engineers might get this map and they say, okay, I'm going to build my existing ground. So they're going to go to the surface menu and choose triangulate and contour. I'll show you a couple of settings to take care of here. Let's look first at the selection tab, far right. And let's make sure that none of these things are checked. If you just uncheck the specify selection object options and the filter selection, uncheck those two boxes to make sure, and the whole screen will go gray except for those two boxes. That's what we want. And as you can tell from what it does, it lets you limit what you look at to only certain types of data if you wish. This is also where, if you have a file of information like like this down here in the lower left, if you have a text file of a bunch of point elevations, you can check that and then check on And you can read it from a coordinate file or from a text file or a point group. Specify your format and read it from that file. You don't have to dump the points into your drawing. It will actually just go out and read the points and leave them alone out in a coordinate file without making it part of the drawing itself. So that could be handy if you've got thousands and thousands and thousands of points and you want to use that. But otherwise, we typically have everything we need in our drawing. So we're going to go to the Selecting tab, make sure those are unchecked. And let's go back to the Triangulate tab. Well, actually, for right now, let's go to the Contour tab and uncheck Draw Contours. That command is all combined together. We can always draw the contours after we build the surface. But for right now, we're going to just build the surface and take a look at things. With the contours unchecked, the Labels tab is completely gray, so that's what we want. Now to the Triangulate tab. And we're going to leave all of these boxes at the top unchecked except for Write the Triangulation File. And then I'm going to select, choose that select button and give it a file name. Make sure I'm in my working folder here. And I'm going to call this one just EG-CTRS only, contours only. So basically what's going to happen is that we're going to build a surface out of just the contour data, because that's the way a lot of people will do this. Not usually surveyors. Surveyors are usually creating these contours. But this also illustrates the fact if all you deliver to your client is a contour map, this may be what they wind up doing, and so information gets lost. Now, we'll come back to this stuff in the middle here in a little bit, but for now, uncheck the use inclusion and exclusion areas. And does your version have this next box where it says shrink wrap perimeter reduction?
Yes.
Yes.
All right, pull down that, check that pull down list and choose none for right now. And I don't care what, because we're not drawing contours, so it doesn't matter what you have this erase previous set to, but for now, I'll just turn them off. Otherwise, if you turn this on and say, and leave it as all contour entities, like if you're building the surface and drawing contours, looking at it, going back and fixing it, and you're rerunning it, it might be handy to have it erase those previous contour entities. But just keep in mind when you do that and you build another surface, it will go and, you know, you might have a part of it or another surface somewhere else that you want to keep, and it will erase those if that's still set on. But that's okay. You can always recreate the contours from the surface file. So it's not a danger other than you might not know why they disappeared. So just keep that in the back of your mind. All right, so we're going to uncheck the use inclusion. We're going to set the shrink wrap to none. We're going to erase previous contours off. We will ignore zeros. And we are going to, let's go ahead and uncheck densify break lines for now. This maximum edge length, interior and exterior, if you set that to about 2000, that will get rid of any long contours on the outside and the long triangles that are over 2,000 feet long, or whatever number you set. Same thing for the interior. So if you had a pond or something in there that was, you know, pretty big, you could limit that if you wish without having to draw boundaries. And for now, we're going to leave all the rest of these unchecked. And we'll talk about them because they are helpful, but not perfect. Okay. So let's say okay. And now here's where it's important. Based on what you have checked and unchecked, the prompts are going to be different, but you're always going to see select objects. And the problem is you get complacent, you get in the habit of doing something with one setting one way. And if you change those settings, you may think you're, picking things in a different order. Always read the line above where it says select objects. So right now it says select the points and break lines to triangulate. And right now I'm just going to draw a window around all of this, or I can just type the word all and hit enter. I'm finished my selection, so I'll hit enter one more time. And it comes back and tells me what it did and that it wrote a file called EG existing grade from contours only. Okay, so built that, gave us no errors. So let's see what happened with that. If
I
we
can't get,
go ahead, say again.
it's asking me to,
I heard you say it's asking me to, and that's all I heard. So your mic, you're muted again, Sally. I didn't hear your question. There you go. What you're muted again. I don't know what's going on.
it's asking me to please specify triangulation file name.
Okay, because what happened when you ran the command and you said write the file, you did not hit the select button to choose a file name. So just give it a name. I called mine EG-contours only.
I didn't get the triangular, I didn't get that.
If you say, Sally, I don't know what's going on. You keep muting your sound. I don't know if there's something that's causing that.
I have to click into your screen.
Oh, okay.
I don't get this menu that you're looking at.
You don't get this triangulate and contour? Go to the surface menu and choose triangulate and contour. And you say you don't get this dialog?
I got,
No, you keep muting. I'm sorry.
I got it.
Oh, okay. All right. And so give me a thumbs up, Sally, or let me know when it comes back and says it built your file.
I'm not seeing a message system variable changed, and it is asking it for a command to specify opposite corner or fence W polygon, C polygon.
Yeah, you're still in the select objects prompt. So once you're through selecting, you need to hit enter to finish. Or finish drawing the window, whatever you're in the middle of doing. That was Savannah.
I don't have the tin file. Yours says C projects 2022. Well, I don't,
Oh, yeah, that's just what I did when I selected this. I just made sure I was in my working folder. So your folder is going to be different from mine. Okay, Savannah, did yours work okay?
Yeah, just doing it again from the top.
That's fine. And that's a nice thing about this command. It lets you keep doing it over and over again as you resolve any error conditions. And it doesn't cause you any problems. It will ask you if you need to overwrite the file, in which case you'll say yes when you want to do so.
I can't find. Go,
Sally, I'm not sure why, but every time you start talking, it mutes it again.
I don't know either. I can't get to that file, so it won't let me get to my projects.
right. All right, let's see, Sally, why don't, let's see, let's let you go ahead and share your screen. Do you know how to do that? Okay. Just choose your share screen button at the bottom of the controls, Sally, and choose the screen you want to share. Okay, there now. So if you, I don't know, where are your data files that you're working on? Where are you putting them? And if you need to, just hit the browse button and that'll put you in the Windows file picker, the button under that right there. So now go to where you've been storing your data. There you go. Now, down below where it says file name, just give it a name. Just call it EG-CTRS only or something like that. Okay, and then hit save. Now you've set your file, you're good to go. All right. Oh, cancel that. Go back and run the command again. Go to your, press escape. Yeah, run the command again. Go to the selection tab and uncheck that specify selection options. And also the filter by. You can uncheck that as well. Now double check the contour tab, make sure that's also off. Uncheck the draw contours. There you go. Now select all your data. There you go. And perfect. So it said that it, well, you had your perimeter reduction set, so it removed, you see down here on the bottom of your screen where it says reduce perimeter past 9, removed 0. So it ignored, it ignored 95 lines that exceeded the maximum length. So let's take a look at that. Let's run the command one more time. And now look at the triangulate tab. And for now, come down to where it says shrink wrap perimeter reduction. Go over to the right of that and pull that down and choose none. And then where it says maximum triangle length, 200 and 200. You can leave those there if you like, but sometimes a 200-foot long triangle would be valid. But let's go ahead and leave it at 2000. So that way you'll get them all. We'll see what happens with these, okay? So say, okay, it's going to ask you if you want to overwrite the file. You'll say yes. Now select your data again. And boom, there's your file that was made, EG-T only. Okay, so that's perfect. Now I will, let's see, I'll stop your share and turn mine back on. Okay, so everybody else got that? Savannah, yours worked okay?
Yes, I ran it again. I was having trouble just with that selection tool, but I figured it out.
Okay, good for you. Now, so let's take a look at what we just generated, keeping in mind that triangles get built based on the elevation data, in which case what we have showing that has elevation, if I look at it with my viewer again, you don't have to do this part, but It's basically all of these contours, some of those blocks. I'm not sure that it's actually read those blocks or not. But if we look at the triangles, we would see that they form between these vertices of the polylines. That's where the contours, that's the data that it read. Okay. So that being the only elevated data that we had, if we take a look at this, now I'm going to go to my view menu. I'm going to isolate layers. I'm going to pick one of my major contours, one of my minor contours, and also in these obscured areas, either the pond or over here on the cemetery mound, I'll pick one of the major and one of the minors there because it's on a separate layer. And I'll hit enter. And now that's the data that we just triangulated. Notice we didn't have to freeze off those other things because we said ignore 0 elevations. Okay. So let's take a look at our surface now. So we go to our view menu, 3D view, and choose the surface file viewer. And we choose our file that we just built. And it's going to load it up into the very same viewer that we had before. Now yours might look like this, or it might even look like this without any contours. Okay. So whatever that looks like, if it's looking like this where all you see are triangles, go to the view control tab and select the icon that looks like a little fishing net with some of the squares colored in. And you can see what it does is it shades in those faces of those triangles. Okay, because what it does is it builds in memory all of those triangles as 3D faces. So they are planar objects. So it's built that, and I can zoom this up and around and I can see, well, okay, it made my pond. That looks nice there, but I've got some little stair-steppy looking stuff in my stream thalweg for that pond there. And if I look over here in particular, let's see, let me get that. Here's a very common problem. And you see these little bumps down the edges of my road. I've got them down both sides. Now, where that comes from is this, and I'll show you what we're going to look at here while we're in this viewer. Let's go back to the model tab. Do you have a model tab in your version? I can't remember when they added that.
Yeah, we have a model tab.
Okay. So let's go to the icon that says add entities, or you can right click it. No, I'm not. Yeah, so you have this icon that says add entities, and that will minimize the viewer, let you go out and add entities. I'm going to add these contours, finish my selection, and now this is the drawn contours from the drawing file. Okay. And so you can get a sense of what has happened here if you zoom in down to one of these areas where these little triangles or triangle looking things are showing. So let's take a look at what we have there. If I zoom in, like right in here, that looks halfway okay. But if I look at this area right here where this triangle bumps up and this triangle bumps up, if you look at that triangle edge right here, You see what's happened is it's built a triangle from the vertex on this contour line. And it's gone all the way over here and found the vertex on the same contour line. You see that's a nose-shaped valley contour. That's the edge of the pavement. And that's the problem. That's why we have to have break lines in our data. Okay, because otherwise we'll get that stair-steppy looking thing. Same thing down here. You can see that one's really bad. Okay. Now, if you look at those contours, if you go to the settings tab and turn on display contours, and let's change the interval to 1 to match what our drawn contours are. These contours, which in my case are orange colored on this screen, those are the contours that if I had turned on draw contours, that would be the way it would draw that contour. It wouldn't come up into the peak. It would lop them off. And so we've got a problem with their surface. If I were trying to look at that as a flow line for a drainage project, my profile down that leg is going to be looking like a set of stair steps. Okay. So that's a problem. Now let's take a look at another area on the site that's also going to be a problem. I go back to my plan view and I see these contours way over here. I'm going to spin that up a little bit. And you see what it did. I've got these contours that wrap around this edge here, and they're supposed to hit a little retaining wall in there, but they just chopped off the contour. So it ran out of data, but it looked across and it found, it looked across from this top line all the way down and found a point down here, and it built those triangles, which I can see if I draw my triangle edges. So you see those triangle edges are what got built. Now, here's what I was talking about. I'm going to spin this around the side where if you are of the type of person, now that because I'm in my surface file viewer, not my data viewer, I have a different function when I choose this pick box. Now, I'm not sure if you guys have this. Go back to your view control tab, choose your arrow. Do you have now down below this option to do a 10 edit?
Yeah, we do.
Okay, so you could actually edit the 10 itself right here. And what you could do something like pull this down, let's add a break line. And I'm going to just get the mouse near, say, this point and say double click it. And I'm going to go across to this point and double click there. All right, so that now added, and I'll go back and get this other icon now so I can spin it around. So you see what I've done is I've gotten rid of that big sort of loading ramp. I could then add another break line, say from here, let's say up to there. Oops, that's too far. Let's turn this. We can go here to here, then here to here. All right, so I could do things like that, and then maybe remove a point. Let's remove that point. And we go back to add a break line from here to here. All right, so you see I can clean up my surface. If I know what my site is, there's a little retaining wall down there. I can say, okay, well, that looks nice and happy. Well, that's all good. And if I exit this, it's going to ask me if I want to save the changes. I'm not going to save those because here's what happens. I've edited that surface file directly, and there's certainly nothing wrong with doing that. But if I have to go back and rebuild the surface, I have to go back and do all that edit again. I need to fix what's going on in here. So I would need to come in here and draw in my break lines from this, from the end of this, so I would draw a 3D polyline. Let's put that on V-topo BKLN. Well, if I do that, it's going to turn the other ones back on. Let's just put it on one called BRKLNS. It will create that for me. And if I go from here to here to here, and then just pick up these endpoints, if that's my intent. Now I've added that into my data. And if I go back now and say, triangulate and contour again, it's going to keep everything like it was. I'll say, okay, and I'll verify to overwrite. I'll select my data, hit enter. Well, now I had a problem here where I had a crossing break line right in there. Looks like I missed an endpoint. Yep, I missed an endpoint. So if I put that here, and I'm going to go to edit polyline utilities. Edit polyline, add a polyline vertex. I'll choose that as my line to go to. I'll choose that point, verify the elevation, and be done. So I now have fixed that error. I'll repeat triangulate and contour, verify again, select my data. Now my file got built. And if I view that surface file now, same one, but I rebuilt it, oops, it says I'm still running. I need to save this file. And it thinks it's still running the viewer. I don't have it on the screen. I'm going to just close this off and relaunch. Which unfortunately sometimes you have to do. Most of the time that's an AutoCAD problem and not a Carlson problem, but this time I think it was a Carlson problem. Okay. Close that off. All right, so now if I view my surface, and let's go back and turn off the triangle edges. I still see I've got a problem here. I missed. Oh, you know what I did? I think. Nope, it was 3D. That's probably coming from this edge all the way down to that edge. So I needed to probably put some breaks in here as well. Let's try that one more time. If I look at my surface, let's now go to model and add just those. See, yep, it went from here all the way out to here. So I needed to have another break line from, say, down in here to at least over here. So you see what I'm doing is I'm going through this iterative process. I'll do another 3D polyline to set this break line from, let's go from those endpoints and go to there and finish that one. I'll draw another one real quick, and it's, I don't want to spend a lot of time here necessarily to focus on this, but just showing you the process whereby you keep looking at this, you keep going back and rebuilding the surface. Oops, let me get the right program there, rebuild it. The surface got built. I'll now view that surface. And now I should have, if I figured out, yeah, see now I've gotten rid of those structures out there. And you can see along these edges was where I built those break lines. And so that limited those triangles from being able to jump out and seeing the rest of see, before it went from here and it jumped all the way out to see this green contour out here. That was the original data. So these break lines now kept those points from looking across and seeing these points, and I got rid of that little wheelbarrow ramp or whatever you want, ski jump. Okay. Now that same concept, excuse me, you could do over here to lay in. Let's go back and get these now. You would lay in break lines down through all the nose points of those original green contours to keep something like this right here from jumping across there. We would go to this nose, go down to that nose. It would have the same effect if I had done this to this. And then the same effect from here to here. And then the same from here. Not from there, but anyway, you get the idea. I didn't say the file, but you would build that break line down that surface. Now, we're not going to go through that as an exercise, but what you would do is in the field, you would identify that, and whether that's an edge of pavement or a curb line or something. You would create that in the field as a 3D polyline. When you survey it with field to finish, you tell it to draw between all of those like points as a 3D polyline. That builds your break line. Then when you come back and do that data, you won't have those stair steps. Okay. So I'm going to go over here and take these three items here out of the picture. I don't need them anymore. Because what we're going to do next is, you've seen the concept of how you need to fix your data when you see obvious problems there. What, ask yourself, what can you do to make that not happen? What caused the problem? Was looking from, say, this vertex all the way out to this vertex and creating a triangle edge. Well, I need something in between there, i.e. a break line, to keep that from happening. And so that would be what you do. And so if I received this data from a surveyor and I needed to build my existing surface to do my engineering design on top of it, if they didn't give me the surface file, or if they didn't give me the break lines, I would have done what I normally did. I would have, or, you know, a lot of people will take this, they'll do this kind of bit. They'll create the surface. It comes back and it says, okay, I built your surface. They go, great, I've got a surface. I'm going to jump in and start designing. What they don't realize, because they're not looking at what happened, is they're not seeing this. See, it's every time I exit that, it keeps, see if they'll let me do it this way. No, still thinks it's running because I hit the escape key. Well, there appears to be a problem with that version too. So in any case, what a lot of people do is they'll get that, they'll run that command, they see that it built the file, and they'll say, aha, success, it did not give me any errors. Well, the problem is it did give you errors. Mathematically, there are no errors. It did what you asked it to do, but it winds up creating those errors. Looks like I managed to lock that one up too. But anyway, so what it would wind up doing is, even though it didn't come back and report an error condition, it still is an error. Those stair steps down the road edges and those wheelbarrow ramps or ski jumps over there on the retaining wall, those are errors, and you don't necessarily see them. And a lot of people design on top of something like that. So when you're preparing your data to build your existing ground surfaces, you have to make sure you get those break lines created so that that surface is correct. Okay, and you can always use those viewers to take a look at it to make sure it's what you're expecting. And if you don't have it, if you didn't get a break line out in the field, you may have the points that you need to connect to make a break line, in which case you just draw it into the drawing. Okay, so that's the process there. When we come back after lunch, we're going to take a look at building this from the actual break line data and those points, the way that the photogrammetrist did it, and we'll see the difference between it. We'll look at you know, putting a boundary on it, because you noticed over here in this area I had all those triangles, those long outside triangles, and there's several ways of doing that. We'll take a peek at that when we finish that part up. Okay, so any questions at this point? I'm going to go ahead and close this. I managed to lock it. Okay, so any questions so far on any of that? Everybody good, or at least have a handle on the ideas anyway? All right, so let's come back, say, at 1:45. We'll shave 2 minutes off our hour just because we spent so much time trying to track down that other problem. So I will stop the share and I will pause the recording. So now the recording's back on, but I'm going to stop this share. let's see, Sally, go ahead and share your screen. Let me take a look at it. All right, so I'm going to request remote control. All right, so now you have your color by elevation on. If you want that off, it will be that. I go to my surface, just double click it on and off, or right click it and choose properties if I can get to it. There we go. Now you can set a different color if you like, or set the opacity. Let's put that all the way up. Full opacity. You could apply a texture, whatever you'd like. So there it's sort of yellow. Go back to my view control. Bring this around. Change the level. Maybe get the contrast up a little bit. Yeah, it's a little too much. All right, so that's probably a good looking thing. I would maybe, if you don't like that yellow, when you go to set colors, nope, apparently you can't preset them in this version. You just have to go over here and set your properties. And set the color to be, there we go. Yeah, something. Now, let me see, let's get 94. Now it's a little bright. I think I'm looking for like 3. And then over here, and probably tone this down a little bit. You know, so you would, find some color combination that you like. Now, as far as getting back to your adding entities, let me see if we can find that. I have here, it's an edit item. Load the scene. Yeah, so in the new version, they let you add solids. Add text. So I'm right clicking that. It's not really bringing up any kind of menu. So if you had those things in here separately, like some of the other modules, like the mining modules, load up block models. So those would be active. They're not for us because we don't have the information. Well, you may not be able to do it if you go into the surface viewer first. I'll try to keep that in mind on yours. Let me see here. Nothing there. Well, that's too bad. If you edit an item, Okay, I can add a surface. Well, apparently I have to wait on that. So, so the way to do that, well, apparently it changed the color of that layer. Let's see what this one is. The topo minor. It's 97. So let's set the major to 73. All right, so it's already set. Ah, apparently you drew the contours when you did triangulate and contour at some point. Yeah, see, there's draw contours. So I'm going to uncheck that for the next time. And so now I'm going to erase by layer. Let me see what else we have on here. Do we have 2 items? Nope, just the one. Okay. All right, so this is minor obscured. Looks like your major obscured might be frozen here. Yep. Topo major. There we go. Now everything's back to visible. Okay, so to simulate what we were doing to look at drawn entities along with the surface, in this version at least, you'll have to go to the drawing viewer first, load up the things you want to look at. Once you're there, go to the model tab and add a surface. If I can, oh, I'm sorry, it's not right click, left click that one. So I'll now add that surface, and then I'll go back to view control. And you see it's color by elevation still because of the last time when we came into the viewer, even though it's turned off. What you have to do there is to toggle this fill in and then turn it back on. And that now will come in with that color set on the surface that you can then change by opening this up and set your properties right there, okay? Now it came in with that color 13 preloaded. I don't. Yeah, see, it's not giving me. It's not giving me surfaces to set. It just preloads that. It's just hard coded. Now, top, middle, and low elevations, if you keep those colors and you turn this on, you see it goes from this red down to the blue. So if you want a little more distinction on those, you need to set your top to something, you know, really visible, like red, and then middle could be green and low, be blue. Again, and you may prefer that, but that gives you a really good color distribution that you can visually see very nicely. You may even want your high spots to be white. You can think of those as the snow on the mountaintops, and the blue is the water down in the valleys. All right, so anything that you want to do in that regard. And then, of course, you can toggle whether the surface is still being displayed. It's just whether you color the triangles or not. And then over on the model tab, if you want to turn the surface on and off, just double click it. Okay. And that should be the nuances of the viewer, which are really there. So if you want to load those up, you're not able to see the you're not able to turn on the surface drawing contours and compare them to these, because you can't load these into the surface viewer, but you can load up these drawn polylines and then add a surface to that viewer. Later versions, you're able to load them both independently. Okay, does that clear up for everybody? I'll stop remote control, and then I'll stop the share, and I'll put mine back on here. Okay, let's see here.
Thank you. That was good.
Okay, that should be a good review for that. Now, the next thing we'll do, and I'll exit my viewer, is let's talk about the way we would do it if we have break lines. So I'm going to go back to my view menu, and I'm going to say thaw/on all layers. And there now everything is back on. And so what I would normally do when we come in from the field, we don't have these contours. So I'm going to freeze off my contour layers for right now. So I'll go to view, freeze layer by pick, and I'm going to pick one of those majors, turn off the labels, pick one of the minors, and then I'm going to go to the obscured area and pick the major and the minor and hit enter. Now, this is what we would normally come out of the field with, and I'm going to verify that by viewing it in my drawing viewer, and I'll spin it up, make sure everything looks okay. And in reality, that's really all I really need to use to build my surface. Now, this was not a field survey, but rather a photogrammetrically compiled map. So I've got a bunch of 3D lines. I've got some building outlines. Now this one happens to be down at 0 elevation, so it would not show up in my triangulation because I said ignore 0. But I've got, all of these building outlines. If I select similar, and then I'll right click and choose isolate object. So you see I've got all of these building outlines. And now in that. Now what that does in terms of building footprints and building outlines, when you build a surface and you have an edge of a building, you don't know anything about the surface underneath the building. So we need to sort of cut out those holes in our surface. And those are going to be what are called exclusion areas. Okay, and then we have two different types of areas. We can have inclusion areas and exclusion areas. So right now, just for a demonstration, I'm going to draw a couple of rectangles here. Just going to draw one like this, and then I'm going to move it into place, say right in here. And let me draw another rectangle. Doesn't have to be a rectangle, by the way. It can be any closed polyline. And let's move that one up to here, for instance. And I'm going to set those on a particular layer. Well, I don't have it named yet. Let me see, do I have a filter in place? So I'm going to just make a new layer. I'm going to call that one inclusions. Select those two rectangles that I had, and I'm going to put them on that layer. Just to be able to see it a little better, let's make it red, and we'll give it some weight. And turn on our line lights. There we go. Now, with this data, and even though these polylines are just down at 0 elevations, stretch this more like this so it covers part of that. So now, if we go back and triangulate and contour this data and use inclusion and exclusion polylines, let's take a look at what happens when we do that. So let's go to surface, triangulate and contour. And right where it said write the triangulation file, I'm going to hit the select button, and I'm going to call this one just EG-test. And I'm going to double check my contour tab. I'm not going to draw the contours. And I'm going to turn on to use inclusion and exclusion areas. Now, what this boundary method, you may or may not see this pull down here on your version, but that gives you an option of how to treat the triangles when it hits an edge. And it's either going to trim that triangle at that edge and keep the part that's inside, or it's going to remove the entire triangle if it crosses that boundary. So we typically want to trim those edges if you have that option. If you don't, just wait till the next version. All right, so that's really the only change I'm going to make, is to use inclusion and exclusion areas. And I'll say, okay. Now it says select objects, but unlike last time where I just windowed everything, read the line above. It says select the inclusion perimeter polylines or enter for none. And notice it's plural, so it can be multiple. So I'll pick that one. I'll pick that one and finish selecting. So I will hit enter. Now it says select objects, but reading the line above, select any exclusion perimeter polylines. Well, I may take that building outline and if I can get to it, that building outline, maybe that one as well. And I think that's about all that we have to worry about there. And I'll say, okay. And now it's still, well, I had too many enters. Let me repeat that. All right, so now X, I finished that. Now I'll take my exclusion polylines. I'll hit enter. And now it still says select objects, but it's changed to what you saw the last time. Select the data you're going to triangulate. So I'll now grab everything. I'll hit enter. Now, I get this message. We'll come back to this, but I've got some places where let's see. I've got elevations set on these. All right, so I'll turn this back to 0. Now we just repeat that command, triangulate and contour. Yes, okay to overwrite. Select my inclusions. Let me turn that off for a minute. Finish that selection. I'll select these exclusions. And now I'll select all the data. Now I still got these two little things. We'll come back to these a little bit later. I'm just going to hit exit for now. And so now let's take a look. I'm going to go ahead and load this up in my drawing viewer so you can see, well, we're not going to see the 0 part. All right, you'll see the effects. When we go to model, I'll minimize that layers that opens up, and I'm going to right click and add a surface. There's my test surface. I'll toggle that a little bit just to make sure. And if I turn this up, you can see what it did is it limited the surfaces to the edges of those inclusion polylines, and it also cut out those building footprints. Okay. So as long as, now, it didn't cut this one out because I think that may not be a closed polyline, that one that said ruins. That's okay for what we're trying to illustrate here. So the takeaway from this is that even though you may have a large amount of data, maybe your project area is only in one spot, or maybe you're working over here on phase 1 and up here on phase 2. You can make one continuous surface out of just those selected areas. Okay. Pardon me, I've lost my voice. So we're going to use that same kind of inclusion polyline. I'm going to select these and get rid of them now. Is what we're going to use to build a boundary around the surface, because if you remember our original surface, I'm going to go back to the surface menu and just draw. Oh, excuse me, good heavens. I'm going to draw surface, and I'm going to draw the boundary only as a 2D polyline. I'll choose my surface file, the original one. I'll open it up, and there was where the edges of those contours were. But remember those long skinny triangles that were out here? See, that was still where that, excuse me, where that surface was. Pardon me, just a quick minute. Let me get a cup of water real quick. I'll be right back. Okay, excuse me. I was hoping that might clear up my voice a little bit. It's not doing great. Anyway, you can bear with my voice. So what we need to do is to create a boundary around our data. So I'm going to now, I'll have that selected. I'll go ahead and delete it. And there's two ways we can do that, or actually multiple ways. Prior to 2019, when you run the command triangulate and contour, you did not have this shrink wrap perimeter reduction capability here. If you turn this on that you want to use them, you have to have them pre-drawn. If you uncheck it, you can have it create the outside perimeter boundary automatically, and it'll do it for you here with differing levels of perimeter reduction, which is sort of like how steeply it cuts into the data. You'll see that in just a minute here. But what we're going to do, instead of doing that, we're going to continue to use this inclusion and exclusion areas. And we're going to create our shrink wrapped boundary ourselves manually. So we know this is the data we want to model. I can see right now, if I were to model this, I'll go ahead and do that. I'll triangulate and contour. I'll leave that checked on. I'm going to write that triangulation file. And this time I'm going to call this one EG breaks and points. And I'll take this. Okay, now, when I select that, it's going to again ask me for the inclusion parameters. I don't have one, so I'm just going to enter for none, and I'll turn the exclude. I won't use any exclusions yet, and I'm just going to grab the data, and it's going to come back with this error condition. We're going to exit that. We'll talk about it in a minute. So now I've done that as a surface. If I load up in my viewer my data and I look at my surface, so I'm going to add that. I'll go back here and toggle this so it gets the color reset. You can see over here all of these triangles. Like if I turn my triangle edges on, set my triangle colors to be, let's make them sort of bluish looking color. All right, so now you can see those triangles that formed out here that are really outside of my data. Same thing down here. Let's go back to my plan view. I've got these long skinny triangles out here. Now, these perimeter triangles will only happen if the data that you are triangulating has an inset that's concave in shape. And if I go back and look at my data, you see this concavity here. That allows those triangles to form in there in the middle. And that makes sense because if you're on the outside edges, it's only looking back on itself. But anywhere in here, you know, a point on this bit of data could possibly look across here and start forming those long triangles. That's what's going on. That's what we want to prevent. So there's several ways that we can do that. We could simply draw the polyline, and I'm going to go ahead and set up a new layer so you can see it. I'm going to call this one Make a new layer. I will call it surf BDY. Or let's call it BDY surf so that alphabetically it's up near the top. I'll set that to be red and I'll give it some line weight so you can see it. And I'll make that current. And I forgot. Now, you could simply do this. You could draw a 2D polyline. That setting the elevation by first point, that's what happened with that last one I drew, and it read the elevation where it snapped to something. So I'll turn that back off. Now I'll say okay to that, and I'm going to turn off my snapping so that I can just sort of eyeball my way around. Thought I turned it off. Well, apparently it's not. Let me try it here again. So I could just do something like, well, it's going to snap to them for whatever reasons. And I could walk my way around the data like this. Come down to here, maybe come in like this. On the point somewhere there in the middle, come out to these points and then C to close. I now have a closed polyline. I may even want to turn this into an arc and trim it up like that. Okay, so there's nothing wrong with doing that. And if I triangulate and contour that using the inclusion areas, say okay. I'll now select this as my inclusion, no more inclusions. I hit enter, no exclusions, grab my data. And again, exiting that, we'll come back to that. So now when I look at all my information, add my surface, toggle the mesh, turn off my triangles. You can see now how the surface only goes out to the edges of that drawn polyline. Okay. So the takeaway from that is you can quite simply draw those polylines. There's nothing in the world wrong with doing that. However, a faster method might be that a command on our draw menu called shrink wrap entities. Now, don't confuse it with boundary polyline. That goes from the inside out. That would be the boundary, like if you run the hatch command and you pick a point inside a bunch of lines and it hatches everything it sees on the inside, that would be that boundary. That's a CAD entity. It's not a Carlson command at all. And we talk about this being a surface boundary, so it's easy to confuse that term. But we're going to shrink wrap these entities. And we're going to choose one of two methods, cross gaps or bounded line work only. And what that will do is, I'm going to cancel this. I'm going to show you a couple of examples here. If I draw this, and let's put a circle, not quite so big. And then all right, now let's change these to be yellow for a minute. Now, here's how this works separately. First of all, I have to turn this into a polyline. Now, if I draw a shrink wrap boundary, it's on my draw toolbar right here, looks like a GIF package, or it's on my draw shrink wrap entities. If I say across gaps, I'm going to set this perimeter reduction to none right now so you see the effects of it. And then I select all this data. That is the resulting boundary right there. It jumps across those gaps until it hits the next item. Okay. So when you have data like these break lines, that's going to let it jump across these gaps. Okay. Now this was with no reduction. I'll show you what's going on with that. If I do the same command, shrink wrap polylines, and if I change that data reduction to high, watch the difference. That now is the reduction. So it went across this gap. It didn't go into the middle, but instead of jumping across that gap, it did come into the middle. It jumped that gap until it hit, came across, and instead of jumping over to here, it pushed it in. And that is the difference between, and let's set that to be a green line. And we'll do one more with none. We'll select all of this except for that. And that one in red. Let's make both of these. Okay, so we've got the red one, which is with no reduction. Back to the front. We have the green one with high reduction. And what that means is this: when it's building this feature, we said go across gaps, and then the this perimeter reduction, none, low, medium, and high. None means I'm not going to reduce the perimeter at all. High means it's going to reduce it more often, like this green one did. It didn't go all the way in places. It still jumped across from here to here. It didn't come all the way back. Okay, so what it's really doing in the background is it's triangulating that data. It's building a little mini surface in memory, building all the triangles, and then it's looking at those exterior triangles, those perimeter triangles, and it's reducing the number of those triangles. That's what that reduction means and why it's called perimeter reduction. Okay, there's nothing to remember more than this is with no reduction, so it doesn't cut into the data. This is with high reduction, so it cuts in as much as it can. And if I do it one more time and set it to, say, medium, and we'll select everything except for those. And that one was exactly the same as the other one. So in any case, it would normally be Let's set it to low reduction. Left everything except for this and this. There we go. There's one that's reduces it somewhat, but not as much as the high. Okay, so there's no real method of figuring out what what it's going to do. It's just a relative level comparatively. All right, so now the difference between that command and the command right beside it called boundary polyline is what I wanted to show you to keep you from making that mistake when you're putting a surface boundary on. It's not the same command. If I choose that and just pick inside, it now makes that the boundary. Oops, let's see. Okay, so that draws a boundary around everything that it finds that encloses the point you pick. So that's a slightly different means of working. Okay. Now, one final point of illustration here is when we draw a shrink wrap boundary or shrink wrap entities, that was the across gaps method. And that's what we're going to use most of the time when we're doing these open-ended line work. But you could also have this as an option. And here's how this works. The reduction goes away because it's only going to snap around the things that form a complete boundary and that is closed. So this one you can see looks at all the data, but it doesn't include this lone part of it out here. It just goes around where it finds it can't go inside any further. So it went here, but this was not closed around it. So it went right across it. And then it hit this, came around, same thing there, same thing there. So that's a really good option if you have, for instance, a bunch of outlines of some areas. Maybe this is, phase one, phase two, or whatever, and you needed a total included area of those potentially overlapping regions, then you would just do a shrink wrap of that and allow it to show you what that total enclosed region is, and you can do an area computation, things like that. Okay, so that's that. And if we draw our shrink wrap instead of drawing our polyline manually, we're going to go to across gaps and we'll set our perimeter reduction to high, and let's select the layer, the boundary surf, and say okay. I'm going to draw this around all of our data, and look what happens. Remember that one that I drew before? It was basically a straight line, a little arc, straight, 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 and then, but this, because of that perimeter reduction, it jumped in where it didn't have any data. Okay, I see something like that. Some of you might have, let's see if I've got, some of you might have a couple of straight points out here on the side. I may have erased them out of my drawing. And if you do, if you have a situation like this, select that and that. Erase that, and let's repeat that same draw shrink wrap. Now watch what happens in this case, because I've included those two little straight points. It's going to wind up doing something like that. Now, here's how to handle that. First of all, you can redo it and not include those points, or keep in mind, this is just a polyline. So you could simply come in there and remove the vertex, remove the vertex. You could add a vertex, bring it up to here, make that an arc if you'd like, you know, any kind of thing like that you need to do. Okay. So any way that you can help it out to form a boundary. Now this is going to include all of that data, and notice across here, when it builds that surface, it's not going to put anything across here, but it will stop it here. So that's a case where you might want to come in there and remove that vertex manually so that you include all of those different things. Okay, so you could do that by hover, remove, hover, remove. You keep doing it that way, or you could choose this command. It is a remove polyline menu, remove polyline vertex, also on the toolbar, remember. I select it, and now I just have to pick near. I don't have to snap or do anything like that. I just pick nearest to the one I want to remove. And now I've cleaned that up a bit to where I will get some surface and information there. Maybe I'll take this one out as well. So any way at all that you want to do it. Now, you may not want to have the edges of your surface all that jaggy. Remember, that was high reduction. So I'm going to erase that, do it one more time. And this time I'll set that instead of none, because I don't want to have to fill that out. I'm going to set it down to low and see what it gives me. Oops. Data. All right, so that is it's a bit smoother. It still, you know, follows all the data. And then I could do something like this to tighten it up. Okay. So any way that you want to do that, you may do it. You may draw it ahead of time. I tend to like to draw mine ahead of time. And if you're going to use exclusion polylines in your data as well, then you need to pre-draw this inclusion polyline so that you can select it when it prompts you for it. Otherwise, I'll take this out. You could do this. Let's triangulate and contour one more time. And this time, instead of use inclusion, exclusion areas, I'm going to uncheck that, and it's going to now offer to shrink wrap my data automatically. I'll set that reduction factor to low. And you have the option here under setup to draw it, make it a 2D polyline. You don't need to have the 3D. Put it on a particular layer. And say okay. Say okay. Yes, it's okay to overwrite the file. And now it just says select objects, but it says select the points and the break lines that you want to triangulate, because it's going to automatically create that perimeter for me on the fly. Now, the reason I like to do them ahead of time is so I can make these little adjustments wherever, you know, when I find places that I want, you know, I may want to reduce. No, it's not. And that's where it starts and stops. There we go. And maybe add some back in here. Now, so those are the nuances of doing that and what those settings mean. And they could be something that, you know, you may choose to neaten up a little bit. But here's the other thing to keep in mind. Let's say that when you generate this surface, and you're going to look at all this data, and you're going to deliver a map and a model to somebody, they may not be interested in this stuff out here on these far edges. They may just really need from, you know, say the edges of the road inward. Then you don't really care what this looks like, or the fact that the surface goes out there a ways. It just gives them a little extra stuff to work with, but it's not that important. So don't waste a whole lot of time trying to get that absolutely perfect. And the key takeaway there is that this entity is nothing in the world more than a polyline. You can see right here in my properties. And you can create that polyline any way you want to do it. You can draw it manually like I did the first time. You can draw it with shrink wrap manually, or you can let the triangulate and contour process do that on the fly. So now, you've got that drawn. Let's do this one more time. And I'm going to now turn back on to use the inclusion and exclusion because I've already got this one drawn. I'm going to make sure this erase previous contours is set to off. Otherwise, when I run that, it will erase that boundary because it generated from this command. But I'm going to say that. I'm going to say, okay. Okay, it's to overwrite the file. There's now my inclusion. I finished the inclusions. And now I'm going to go up and grab these building outlines, and this one was not closed. And besides, you see all those ground shots, those spot elevations? That's just a border that says these are a bunch of ruins. So it's not really a building. So I'm going to get all of these building outlines. As my exclusion areas. And now, when I finish that selection, I'm going to select the data I want to look at. And there now it creates that, and it brings up an error message. And I'll show you at this point how to resolve these errors. We have 3 potential errors that can happen when you're building a surface. You can have crossing break lines. You can have T intersections, which are just the same thing as crossing break lines, except it doesn't go ahead and cross it. It just ends at a T intersection. And we have vertical edges. And what that means is it's looking at all the data, and it's looking at all of the elevations of all the points and all the data. And it says, you've got a 3D line, you know, say that goes from here over to here, and you've got another 3D line from up here down to here, and they cross, and where they cross is not at the same elevation. So if you open up these items, you'll see, and you notice there's a little arrow that keeps moving around that shows me where those things are. We got a vertical edge, a vertical edge. So that means that there's something that is over top of another one vertically, but it doesn't match. Now, when I just said exit before, it went ahead and chose which one it was going to use, but you need to resolve those if there's a problem. And you can tell that there's going to be a problem by looking at this number in parentheses that tells you how far out that data is away from being the same elevation. Now it says it filtered 14 errors because they were below my tolerance settings. And if I look at my settings, I'm saying that I'm going to flag an error if vertically they differ by 0.0001. Now you can make that a little more realistic, like 0.01, and you may not see any of these. Well, you would see these two vertical edges and these three up here. Okay. And you can choose to draw where those errors are. So you can go then and find those little marks, you know, where it puts it on this layer if you turn to draw it on a certain size. That's my settings. But now when I look at each of these, it tells you down below here, the X and Y location and the Z difference. That's the same number you see up there. Here's 0.000, which is really 0.00049. So it's close to the same. But now, every time I look at these things, it's going to show me this little arrow is going to point to where those are. And if I look at this one, for instance, that's 0.3 difference. I've got the zoom to, which puts it in the center. And I've got zoom in and zoom out that I can do. And if I look at this, I'm going to zoom in. Now I'm just going to click over here because I can still work in this drawing, even though this is open. And I look at these two items, and they are, well, actually there are 3 items there, sorry. One of them is probably down at 0. So I'm going to, you know, make one of those. It's on layer break line. I'm going to change that one to red. I'm going to look at this one. It says boundary surf. It doesn't look right. How many do I have here? I've got 2. Okay, so this boundary. All right, there's a 3D break line. I'll make that one yellow so we can see it. Now let me select. That one is the head wall. All right, so both of these are, and if I were to look at these items, I'm going to isolate and hide. I look at this item, I see it's on a layer called V storm head wall. Now that one's 0 elevation. That's not being triangulated, but those other 2 were. So that's a head wall. And if I look at that a little bit in, let's look at that in my 3D data viewer real quick. And you can see when I spin this up that, yeah, they do indeed cross. And they're at a different elevation where they cross. Okay, so I need to figure out how to fix that, or really, you know, I would send that back to whoever prepared the data and say, hey, tell me what you meant by this. So they just got in a hurry and got sloppy. So what they would, you know, what you would probably or possibly could do is just, you know, pull this off a little bit. Make sure I didn't set that back down to 0. Yep, that's good. And I would pull this guy out here a little bit, make sure that's not a 0. Good. So now they no longer cross. I verify that in my 3D viewer just by selecting those 2 items. And I look at it like this and I say, okay, that's in good shape. Now, really, it's still an error because it wasn't surveyed correctly. If you got the foot of the wall and the top of the wall, make sure they don't cross when you're doing the surveying part. All right, so now I'm going to put these back to their, oops, by layer color. And so I've cleared that one. Now it's still here until I run the command again, but I know I've cleared that one. I look at each of these. There's another one where it crossed, but I fixed that one as well, so that will go away. But now let's go to this one and let's zoom to it, and we can zoom in. Looks like it's right in there. They actually cross at a slightly different elevation. And again, that's probably, this is on an edge of a road. This is an edge of a road. So they compiled one edge and got a little bit too far on this particular spot. Easiest way to fix that is to simply break it away from that edge. So that's now fixed that one. And I've got a couple of more here. Let me see this one. Crossing break line. It's actually showing me 2 indicators, but it's way out here on this outside edge. I wouldn't necessarily worry about that one. And it's that 0 difference, 0.0027. Oh, and the reason I'm getting that superimposition is because I'm slightly out of perpendicular. So there now is where you see where that crosses. So you would either trim those things back or join one to the other. Or probably easiest just to do something like that. Well, you don't even need to worry about that one. You just leave that one as it is if you'd like. And I have the other one. See where they cross. Well, I could even put it right at the, it's not the intersection, but I could then to behave itself here. It's not. There we go. And I need to open that up just a skosh so it's no longer touching. So now I've cleared those. I've got a vertical edge. And I see the same thing. Now what's happened here is I look at those in 3D. And let's put an exaggeration on it here and see if we can find it's right in here. Not sure exactly. So that edge comes down and it's right at the end of this arc, probably a curb line, right as it hits that edge there. So I would see that arc comes down and it hits this line, which is vertically right over top of this one, but at a slightly different elevation, 0.04. So you could either break this one apart or you could simply slide this one back, snap to the nearest so it stays on itself. And this line is just the planimetric curb line, and it has a 0 elevation, so that one's not going to be used anyway. That's that vertical edge. I find this one. I've got the similar situation. If I spin that, oops, a little too much. Zoom 2. So it's right in there at the corner of that. Curb. I've got one line here and it joins onto that one. So they're vertically, see that vertical separation. So I need to bring this one up to that one. Now I fixed that, go back to my plan view. Now when you run the command one more time, again, remember we're fixing the data. We're not editing triangles. So I'll now select my inclusion, turn the cycling off. Select my exclusions. So this building, this building, this building, the ruins are not an exclusion area, that building, and this building. And now select the points and break lines to triangulate. I'll select them all. And now I still have a crossing break line, but it has, you know, wherever it happens to be, it won't even let me zoom to it because it is underneath that value. And if it's that close in value, there's no way I'm going to waste any time trying to fix it. It also filtered 14 other errors out that were underneath that value. So I'm good to go with that. And I'll just simply say exit. I've now made my surface. And it's going to look like when I view my surface file viewer, this. Contours are on at 1, my vertical scale's at 1. So you see now the inclusion went up to follow my shrink wrap boundary that I modified, and it clipped out those building footprints. Okay. So now you notice, if you recall, back when we, excuse me, back when we built the surface from the contours, remember that little ski jump that was back in here? See how nice that looks like as a little retaining wall, which is what that actually is. Same thing over here on this raised island. And you can see the curbs are all nicely shown. Everything's nice and exact. Whereas if you did that from just the contours only, this would appear flat all the way across this feature, and you would not see that raised curb. Or you would see it go from down here straight up to that contour in there. So that's why these break lines are important and why you need to always visualize things that when and where you can. Now I see a little sliver triangle right in here that may or it's not significant. But when you see things like that, you need to ask yourself, you know, I'll change the shading there so I can see it a little better. And, you know, there may be a point in there that really shouldn't be triangulated. So you could go back into the data, find that point and get rid of it. That's my preferred method. Or you could then edit this surface by, let's see, I'm going to remove that little high point there. That little high point there. Looks like I'm getting myself into trouble. Yep, I did. So I'm going to undo. That, and let's see, if I've got triangles that come across here, I maybe need to put a break line in there. Say from here to here. Well, that took care of that one. Let's see if I did one from there all the way down to here. Yeah, see, I'm just really kind of getting myself into trouble trying to fine tune those areas. Okay, so I'm not going to save this edit, but that's the point at which you could do that. You see another little indicator here. Maybe there's something that either should have a break line across here, or we would maybe get rid of that point. Well, that wasn't a very good option. Had a break line, say from here to here. And that healed it up a little bit better. We've got maybe, but can only go to the actual triangles. There we go. If I don't want this triangle edge to form, I could put a break line from here up to here, except it's not able to add that one. I could swap the 10 edge. So you see what you're doing there. You know, it might be something that you could fix with an edit like that. Again, I'm not a big proponent of direct triangle editing, but sometimes, you know, that's what you can do to fix things. Also, you can look at that and say, well, you know what? For the purpose of what I'm doing, I'm not going to spend the time it takes to fix those little bitty errors. I can live with this. You know, I could go back and look at the data, make sure it's correct. If it's not, fix the data. I'll say no, I'm going to save the changes. Or if it indicated some kind of error in the field, I could fix that observation or remove a point, take it out of my model consideration. Any number of different ways to fix the data, go back and model the surface again, and then you know, keep checking it. Keep using that 3D viewer as a visual check on what you're creating. Okay. So any questions at that point? We're going to go ahead and take us a 10-minute break here. If somebody's got any questions. Everybody good with that? All right, so we'll come back at 2:30 and we'll finish out the afternoon. We're going to look at some couple more tools. We're going to do some profiles and center lines. And a couple of other little visual QA/QC tools that we're going to use to evaluate our data. Another real quick and handy way to visualize some of this stuff. Okay, so I'm going to go ahead and save this. Everybody's good. I will turn off the share. I'll pause the recording. I'll go ahead and turn the recording back on. And there we go. There's Scott.
I'm here, Sally. Just so you know, my computer crashed and I lost a lot of the information, but I tried to gain it back as best I could.
Okay. Were you able to make a surface using the break lines and the points?
I believe so.
All right, I mean, you can load up your 3D surface viewer and see if they're, you know, see if it shows with the curbs and everything. like on, you know, see if you got this where it shows.
No,
it
not
does-
that far.
All right, so if you freeze off those contour layers, in fact, if I turn everything back on, I'll step you through that real quick, okay? So I've got every layer is now turned on. So I'm going to go to my view, freeze layer by pick. And I'm going to zoom in and pick one of those major contours, the major labels, the minor contours. Then I'm going to go to the obscure area and pick a major and a minor, turn them all off. And now you should have the data that you need to build that surface. And just go to surface menu, triangulate and contour. Go to your contour tab and uncheck draw contours. Look at your selection tab, make sure those are unchecked. Go to your triangulate tab. Make sure it says write the triangulation file. Hit the select button and give it a new file name if you want to name it a new one, like in this case, it's EG-CTRS, BRKS, and PTS. That shouldn't have said the CTRS. I meant to just say breaks, but apparently I mistyped when I selected it. It doesn't matter. And you can either use the inclusion exclusion areas if you've drawn this separately. If you have not, uncheck that and set this shrink wrap reduction to low. Ignore 0, hit OK. Confirm that you want to overwrite if it's asking you to, and then just select all that data. And when the error box comes up, go ahead and just hit the exit button. That you can ignore those errors for now, and that should get you back. Okay. All right, so now let's go back to, I'm going to go back and turn on, I'm going to thaw and turn on all my layers so I can see my contours just for visual reference. And I'm going to likewise go to my view menu and I'm going to freeze layers by pick. I'm going to pick one of those 3D break lines and one of these magenta points. So there now is my sort of what they delivered in terms of a contour map. So I can see that for visual reference. All of these lines that you see here that look like break lines, those are the 0 elevation planimetric features only that that they've compiled and left down at 0 elevation, so I can do my mapping if I want to change it to a different line style so it would show up. So that would be a different line type. You know, maybe if it were a dashed line or something, you could set that accordingly. Set my LT scale. It's a little better. So I'll put this now back. All right, so now I'm using this just as a visual reference, but what we have underneath all of this stuff is a surface. So let's take a look at another means of evaluating our surface information. Up here's that retaining wall that we modeled correctly once we used the break line information. Now again, this one's at 0. elevations. So see, it has an elevation over here of 0. So that's just there planimetrically to show you the outline of the wall. That's not in 3D, but the break lines that we froze were in 3D, and that's what contains that surface within that area. Okay. So let's take a look at that. Remember our little ski jump that we had out there, and we're going to go to the surface menu. And we're going to come down here and we're going to use this command called quick profile. And if I turn that on, I can look at a quick profile of screen entities. If I had those 3D data out there, I could look at this is much like the 3D viewer. So screen entities are things that are drawn in the drawing, or I could choose a 3D polyline if I had one drawn in the drawing, or I can choose a surface file, and you may or may not see file names down here. Now, what they are going to be is the opportunity to look at 1 or 2 surfaces for comparison. So I'm going to load up, I'm going to hit the first button. I'm going to find that EG contours only as my first one. My second one, I'm going to hit the select button and choose cancel. Just so I'm looking at one surface only. I'll say okay. And now it wants me to either pick a starting point, or I could use a centerline file or a drawn polyline. So I'm just going to click from here and I'll go across to here. Now I could keep going, but I'm through it. That's all I want to look at. I'm going to hit enter. So now what shows up is a profile viewer that shows me the data in that surface. Let me get this up out of the way a little bit. So as I track down here with my blue crosshairs in my profile view, I'm reading out the station along that line, the elevation, and the slope. You see those numbers over there changing. I can set a vertical exaggeration. There's the no exaggeration that is set to fit the window, or I could set it any number of those means to look at it. Okay. So there it is. But now you see how this line, if I look at this drawn map, and I can click up in here and zoom around and pan so it's fine. Then I'll click back down and below in this window below. So you see what is happening is I start here and I climb up this slope. I'm looking at the profile now, and I go flat across the top to right here, and then I come down the slope and come back to the bottom. But there's nothing up here in my data that indicated that, and that's because this was that original surface file that I looked at. All right, so I'm going to exit that for a minute, and I'm going to right click and repeat quick profile. And this time I'm going to look at the first surface. I'm going to change that to be the one that had the break lines, and I'll compare it to my contours only. I'll say, okay, I'll now click and hit enter. And now you see the white line that's tracking with the blue crosshairs in my profile. That's my first surface, and that's one I set to be the good surface. And you see the red surface shows you those areas that had those little ski jumps in them. So you can see how we verified that we cleaned that up. Okay. Now another something nice that this will do is if you go up here and we'll look around here in plan view a minute. If you have clicked points to show the profile that you wanted to look at, then over here on the right, you've got this button that says adjust alignment. So if you click that, Then you go up here in the plan view, and if you click closer to the middle, you're going to pick that up and drag it. And you can see in real time, it's showing you the comparison of those two surfaces. Here I'm going across that little pond, for instance. Come down here and go across my valley. Now, it might be that like right in here, you know, I was, maybe I'm skewed and I want to change it. So if I adjust the alignment, if I click nearer to the end point, I can swing it from one edge to the other. So if I go across like that now my marker is down here. And if I look right in there, you see right in the bottom of my stream, you see my white line again is the correct one. Now I'll click down here. Oops, let me zoom that one in. And up here, you see as I'm tracking, you see where I am. So my surface that used the break lines actually picked up the bottom of that little stream channel, whereas the red surface missed it. Okay, so you see that difference? And to show you also over here where we had a problem, I'm going to go ahead and exit and rerun the command using those two surfaces. And I'm going to just come down this road edge, say from here to here. Just keep coming down. And let's give it a 2 time, 5, maybe 10 time. Well, we'll zoom in down here. But you can see, let's give it. You can see as I go across here, the difference, the white surface is the one where we used the break lines. The red surface was the one that had those flattened areas in it. Get that repositioned. And then if I adjust the alignment, let's see here, if I come in a little bit like, let's see if I can pick up a real severe difference. You know, you can see that difference in the surface modeling in that spot. Okay. If I can do it one more time. Let's do it just right across from here to here, for instance. And now when I adjust the alignment, pick up these. And there you can see where the red line was that original from contours only. You see that's where it flattened across. But when we used the break lines, it went ahead and got down at the bottom of the edge of pavement. Okay. Same thing. If we take a look up here, let's straighten it up a little more perpendicularly. Now you can see how our red surface from the contours only did not pick up the curbs, whereas our white surface shows that we did. Let me zoom in up here a little bit. You see as I track this down, comes down from that edge of the pavement, hits that face of curb, climbs up the curb. It's a triangular curb, comes across to the back. If I look at it with a one-time vertical exaggeration, it'll show up a little more correctly with those wedge curbs. Okay, so you can see, even though our original surface that we built from the contours, we could turn that in, it would still, if we drew contours from it, we would still get contours that pretty much look like these, except for those severe cases. But you wouldn't see those little nuances like that raised curb structure. And so that's what we're going after, is to be able to create this model correctly. And as this is a little tool, one of the things, let's say you're looking at a problem area and you're trying to figure out maybe what's going on with it, and you want to draw this thing out. And I'm just going to take the defaults right now and see what happens with it. I'll put it over here. Whoops, I guess it. The mouse is sticking, so it's issuing too many returns. So this is obviously not, I don't have my colors and my scale and all that set up, but you could actually, draw it appropriately and set that up and try to use that to figure things out. I'll grab the contour line too, so let me undo. Okay, so what the heck is this? Oh, those are my grid text. There we go. All right. So that is really sort of, a deep dive into modeling these surfaces. And the keys to sort of take away from all of this is to understand the importance of those break lines, why you need them, and what they can do to help model the surface, and how you can correct problems in your data by looking at your results, going back and forth, and continuing to model until you get things right. Okay. So with that, let's take a look at a couple of other things. You can save that drawing if you'd like. There's no need to. I'm going to go ahead and close this off. And let me see if there's something else we can look at. Let's do a little bit of looks like Scott had dropped off. He's coming back on. So let's do a little bit of final wrap up. So we've gone through all of that, and let's do this, putting everything together. We won't have quite so much data in our way. And so what we're going to do is we're going to step through this example, and you should be able to, the workflow in this is going to sort of reinforce everything we've done for the last couple of days, including points, drawing, boundaries, computing a surface, and all of that. Okay, so let's open up a drawing called example1.dwg. So I'm going to come back here and open, I'll go to my data sets, and I'm going to look for example1 DWG. Whoops. I get the wrong one. All right, so example1 DWG. Open that. And go ahead and choose continue opening file because it was last done with the IntelliCAD version. That's why you get that warning. All right, so what we have in here, if I do a zoom extents, see a bunch of Carlson points. If I do my view, 3D view, drawing viewer, and I select everything, I see, well, yep, there's my points, and they show up. I'm exaggerated here, so I'm going to pull that back down to 1. So there's my points. It's a little stockpile area. And I've got some descriptions here. I've got some that say B and some that say B-toe. Now I'm going to look at let me see, I don't need that for a minute. I can change that style if I wanted, but in any case. So I've got this B-toe. If I look at my draw text set style, I had this point style that was used to set that up. I'm just going to make that a little more pleasant to look at. So there's a bunch of points I've got drawn in here. I've got my point symbols on. Let's go back to my AutoCAD settings, my point display style, and see if I don't think yeah, it doesn't change it from what it was last set. It sticks with the drawing, so we're good shape there. All right, so now, how would we, and go ahead and unmute so I can hear some answers, but go ahead, how would we build a surface out of this stockpile data? How would you go about that? Just free association. Tell me what you're thinking.
Break line on the toe.
Yeah, you do want to break line around the toe. Good choice there. We want to put that in there. And so what's a good way of doing that?
We could freehand
Drop.
draw the line or shrink wrap.
Yeah, we use a shrink wrap. It's very good. So let's go ahead and draw a shrink wrap. And we're going to let it go across gaps, remember, because we've got this gap down here. We'll say okay. And we'll select our data and hit enter. And I look at things that, here's my resulting polyline. Let's change that layer. I'll turn on my all right, so let's go and examine this now. We see a couple of misses. See this one here that got missed? And over here is one that got picked up that really is not a toe point. Should have gone from here straight across to here. So the obvious way, because this is a very simple data set, I can tell this by simple visual inspection and come in here and right click, hover, add a vertex. I'm pointing to the description because my point snap is on. So I'll do that. And then I can come over here to this one, hover, and well, I'm not getting, I don't get the delete vertex because I'm guaranteeing you that that's where that polyline starts and stops. That's its begin and end point. Okay, so you can, if you wanted to resolve that to be able to click that, you have a tool under your polyline utilities, and you can edit the polyline and you can set the polyline origin. So if you choose that, I'm going to come up here and set the origin up here at the top. And it says pick near the origin point. So I'm just going to pick over there. And now I should be able to come down here and hover the mouse, and there's my remove vertex. All right, so that's a way that I could do that one. What's another way? I'm going to erase this now. What's another way I could do this? Let's say if I were just drawing it, of course I could simply, hover, 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 work my way around it. Again, it's a small enough data set, I could do it that way. Okay. What's yet another way?
Could you draw a 3D polyline by description?
Yeah, you could. It doesn't have to be 3D though, but it could be. The reason it doesn't have to be 3D is because what we're wanting is a boundary to enclose our surface, and we have the points to be able to read them. But let's say that we did draw it as a 3D, and it's okay to make it a 3D. Then when we triangulated our data, we wouldn't even need to include the points because the polyline contains those vertices at that elevation, so they would serve the same function. But either way would do that. So if you draw a polyline, no, let's see. I draw, gee, we're going to do this. This is not going to that. I can't do it on the draw polyline. Where was the? So my nearest found. Let's see. Yeah, I don't really see this option. Do you have that in your command set? If you draw. Can't really draw based on that description. So who suggested that? Draw a polyline based on the point description? We're
Yeah,
heading,
that was me. I was just guessing.
I know, it's a great guess. I'm glad you said that because it really is the approach. And I thought there might have been an option to do that under the draw polyline. I don't see that there. However, here's the way we can do that. If we could draw this polyline, go point to point as we're going, but remember our point groups. So if we have a series of points that just have our group showing and not these other ones, so that we don't get that pull in here, then we should be able to create that. So if we want to create some point groups to be able to limit what we're looking at and working with, we would do that how? You go to your point groups, your point group manager. Now notice what happens here. The point group manager says, well, tell me which coordinate file you want to use. Well, I don't have one. I opened an existing drawing. It did not have a coordinate file associated with it. So I need to make one. I don't think there's one down there. I think we're just going to make it. So we're going to say a new one. We're going to say open. Well, the new one here is, I don't have any points in it, even if I create a new group. And let's call this, perimeter. So you can read it. And if I said, wanted to include it by description and called it B-toe like they have it, and I'll say, okay, there it is, but there's no points in here. Why is that? Where do these points exist? Where does point 2077 exist? In fact, if I wanted to draw a 2D polyline and I wanted to go from, say, point 2077, see what it says on the line above, requested point 2077 has no coordinate. I'll press escape. So what that's telling me is that, all right, I've got a bunch of points in the drawing, but I don't have them in my coordinate file. Okay, so this is what happens sometimes. We usually run into it when we get our drawing out of sync with our coordinate file. But we have some techniques or some tools on our points menu that we're going to be able to pull these in. Now, you see under point utilities, one of these options down here is to update the drawing from a coordinate file or update a coordinate file from a drawing. So that is how we synchronize the two to match. So we're going to update our coordinate file from the drawing. Now you can do it from that menu, that's fine. But up here in the top part of the menu is a coordinate file utilities command, which brings up a lot of those commands that you see on the points menu that are all here contained in one tool. Things on the left tend to work with the files themselves, the full coordinate files, whereas the things on the right work with points and ranges of points. So one of the options down below is to update the CRD file from the drawing, the lower left button. So if I choose that, and now here's where you could only bring in certain points. You could say up here B-toe, and those are only the points that would go into the coordinate file, but we'll take them all. Let's go ahead and build them all. We'll say okay. And now it asks me to select objects, and it's asking me to select Carlson, land development desktop, soft desk, inroads, all those different types. So I'll just select all of those. finish my selection set, and then hit my list points button up here. Choose all, say okay, and I see there they are. I've got B points and I've got B toe points. Now here's something else to notice. I start with point 2000 and I go down in order to point 2028, and they all B toes, and there's nothing else but B points. So I could also draw the polyline. Now that I have points in my file, I could say 2000 to 2028. That's another option. And so we'll exit that. Now we have the points now also in our coordinate file. Now, if we go to our point group manager, we built the condition and they show up. Let's create another group called interior points. And this time we will include everything, but we'll go to our exclude button and we're going to exclude the B-toe. It's just another way of building the set. Okay. Oops, sorry, cancel that. So now interior points, they're all the B's that you see here. The perimeter points are all the B-toe.
Yeah.
All right. So now we have our two groups built. You can freely exit, or I mean, erase these points if you want. You could freeze points, and let's freeze the point group interior points and say okay. And we'll freeze everything about them. So now we're left with just those. Even though our points, they're actually still in our drawing, but they've been temporarily frozen out of our way. Now you could shrink wrap that, or you could draw your 2D polyline. And this time I can go from 2000 to 2028. Now notice it doesn't end there, so I simply type C to close to make sure it's a closed boundary. So now I'm going to go back to my points menu, say thaw points. Okay. Everybody get a good handle on that part? Some options to generate this geometry. Poor Scott keeps dropping off.
Okay, so I just noticed I can freeze points, and it looked like we could freeze them by point description there as well.
Yes, you certainly can. You don't have to build a group. You can do those by descriptions and do it that way as well. Okay, so it's just a little more practice in setting up your groups. All right, so now you have a boundary. It's 2D. Okay, so if we build a surface out of this data, let's go ahead and do that. We're going to go to the surface menu and choose triangulate and contour. And we will say write the triangulation file. I'm going to hit the select button and I'm going to call this one stockpile. Okay. And I'll go ahead and choose to use the inclusion exclusion areas because I've already drawn it. I will ignore my zero elevations. And for right now, I'm going to, we'll leave it at that for a minute. And I'll say, okay. I'll select my inclusion, no further inclusions, no exclusions, grab my data. Except my mouse keeps issuing too many. There we go. So now I've built a surface called stockpile. I'm going to view it. Make sure it's okay. There it is. Kind of crude looking because I don't have much data really. You get this nice little flat area in here in the front, which may or may not exist, probably does, but it's not being used. Okay. Now, if we look at our 3D viewer again, I'll grab these. They're just going to be points. And if I go to model and I add my surface, I'll come back to view and toggle that color problem. Now you can see the surface and where it connects and how all the triangles formed. I'll go to the settings tab and I will display my triangle edges. So there's some triangle edges and how they formed. And you may notice that, you know, what defined this big giant triangle here in the middle in the front is I start a triangle here at this point. I go all the way up to this point. I do this point as well. And then I go all the way across and all the way up. Okay, so that could be a very, and that could be what really happens. I'm not saying that this is always what you want to do. However, a lot of times when you have long straight edges of something and then you got a bunch of points in here in the interior that you'd like to make triangles back and forth between, you don't have any data except for the endpoints. Except now we have a tool, and we used to do it manually by this command, edit polyline utilities, and we would densify the polyline vertices. And that actually adds extra vertices along the selected polylines at individual locations. And what that does is it adds data into your drawing. But we now have, with our triangulate and contour command, the ability to do that internally. Now you also have that in your list as well. I'm going to set that interval to 2 feet. I have no idea. You know, that's going to give me more than I need, but I'll say okay. Say okay, yes to overwrite. I'll select my inclusion, no further inclusions, no exclusions. I'll take all the data. It's built my surface. Let's go and look at that surface again. So stockpile. And if I turn the triangles on now, well, it didn't have enough in there to generate. I'm trying, let me get a better sense. If I come back out to here to surface, draw surface, I'm going to draw the triangles. And let's just use lines. And it looks like, yeah, there was nothing there. All right, I'll erase by layer. Select that line. All right, so let me draw something in here. Oh, let me undo that. I'll draw a 3D polyline from here to here to here. Whoops. There we go. Now, that has those as a break line. And let's go ahead and densify Maybe 2 feet. 2 feet's a little too much. Back to polyline utilities, I'm going to reduce the polyline vertices. Take the default for that prompt, select that. Now we should be back to there. Let's use 5 feet. So if I edit and now densify, five feet. So now you see all of those would be included. I'll show you the difference here. Oops. If I uncheck this densify and I choose this as my inclusion, no exclusions, get all my data. Now look at the surface now. And you see these triangles that formed up here. They hit all of those little vertices along the way on that 3D polyline that I drew. But I still have this very large flat surface out here because there were only these 2 points, okay? So when I look at that as a, oh, I've also got a bad spot. Another good reason to look at this stuff, right? So let's reduce my polyline vertices one more time. And now let's fix what I should have done and didn't, was to look at this in 3D and see, oh, I've got that bad point out there. I need to fix it. So I'm actually going to just turn it like this. Go to my settings tab, hit my saved view, and then exit. And I see right down there, that is what happened. It snapped to that point instead of to that point right there. All right, so I'll bring that back up. Now I'm happy with it. I'm going to go back and hit the top button on my view cube. Scroll here and say I've got a straight point out here. And that sometimes happens. That actually happens as a result of some of this command. It never was there before, and it's just an AutoCAD point. So I'm going to select it and hit delete. Go back to zoom extents. Now we're good. So now if I build my triangulation file, I'll select my inclusion, no exclusions, select all my data. I look at my surface again. Oh, it's back to the original. I need to densify this one to get the points in there. Maybe 5 feet. Okay, so now I've got those will also make triangles. I'll triangulate and contour that one more time. Now, if I look at that surface, now you can see all of those little 5 foot apart vertices along that line were formed, but I still have this large flat triangle out here, which could be valid, but in this case, probably isn't. So a way of doing that now, automatically doing it without without having to densify this polyline, is when you build the surface, I'll go back to it again, I'm going to now densify my break lines. Next time I'll set it to 5 feet. I'll select. Actually, it's not going to. It's not going to work because that's a 2D. All right. So, to finish illustrating this point, I need to make that a 3D polyline, which you could simply erase it and redraw it based on those point groups, or there's a way of doing that as well. I think have it. What here? Yeah, we just have to erase it. The civil module has tools to have this line go through and read the points even after it's drawn, and it sets its elevation accordingly. So I'm just going to erase it and recreate it. As a 3D polyline. Not prompting for surfaces. Put this on down the surface layer. I'll say okay, and I'm going to go from 2000 to 2028 and close. Okay. Now there it is. It's a 3D, but it only has those 2 points in it. So now, if I triangulate and contour, and if I turn densify on and say okay, I select my inclusion, no exclusion. I get all my data. And now go back and look at the surface. And you'll see a difference in the triangles. See, what happened is that it created triangle points out here every 5 feet. So that helped to really sort of smooth that out instead of coming over so flat, you know, in a wedge shape. Really smooth that out. Now, one of the things that we would probably do, you may see this, have you, any of you guys building surfaces, you ever see your contours do stuff like this? And if you do, how do you go about fixing those? Anybody not see those before, or is anybody see these before and typically do some kind of repair to that? Okay, sounds like no.
Yeah, do some flip faces and stuff like that to make it look a little bit better.
Yeah, that's what I was looking for. The common the common approach to there is to swap the 10 edges. And so you go in here and you would do something like, you know, flip that around, flip that one around. You know, you would do this until the contours look like what you're expecting. Well, the problem is that may or may not really reflect what's going on. What you're doing is you're making a pretty contour. Okay. So we have to be careful with doing that and get out of this and say no. So what you might really consider doing is creating a series of break lines that go across here and to fill in this information out here. And you would do it like you draw a 3D polyline. I'm just going to grab each of these endpoints and I'm going to put it up here. Sort of somewhat Oops. Just sort of, building something like that. Now the civil tools, again, I could just draw 2D polylines across there, trim off the edges, and then have it raise the elevation based on the things it crosses. Let's see if there's anything under. Yeah, no, it doesn't really let you do that. So we would continue to do it like this. Set this. I want to use endpoint first. And set my nearest. Then let's go over here and just do a couple of the ones in that problem area so you can see how it resolves. All right, so we would do something along those lines. And now, again, what we should ideally have are points in between here. Right now, all we've got are a bunch of drawn lines, and I would finish filling that part in as well. But because we have this switch to densify those polylines, it's going to add those as vertices. Oops. In all of those crossing lines. And it only does it in memory. So you see, and it doesn't clutter up my drawing with the extra points, but it gave me extra triangle points. So you can see from the resulting contours here, and let's even turn that down to half-foot contours. So you see how much smoother in the areas where I had those that it made my contours. I still have this giant thing here, so I could have had, a couple more in there. I've got a little valley line here, perhaps. I would have created that as a break line. And then maybe even from there to there. Let's see. It's not. Let's see if I go from here. Yeah, still not able to do it across there. So, you can use a number of techniques to densify your data, make it better. Now, again, just having done that, to illustrate that the technique and the tool, this is not something you would do for a stockpile, right? You wouldn't go to this effort to try to clean that kind of stuff up. But those are some of the things you can do to improve your surfaces. Now, how would you find the volume of this stockpile? How do you compute the volume of a surface? Or more correctly, how do you compute the volume of material between two surfaces? You have to have a reference surface, something that it goes from, and that surface that it goes to.
You take the difference of the integrals.
Yeah, the difference of the two surfaces, correct. So right now we've got the one surface here as the stockpile. What's the other surface that we compare it to? Thoughts? Guesses?
The toe.
Yeah,
Just
we're
do a
gonna make a
flat toe to toe.
surface. Yeah, we're gonna make a surface out of the toe by itself, the toe slope. So it's as if we had taken that surface here and all of this stuff in the middle, we just sliced it off and made a surface out of the outside edge. So it's going to go streaming across the bottom and form the bottom of the surface, because now in most cases that stockpile is going to be sitting on relatively flat ground. So we could say, you know, find out an average elevation, 390, 391. Over here's 396. So we could find out an average elevation and do accordingly that way. And or we could do it like we've already got our data to be able to build that surface that's just the toe. So that's what we would do, is build the base out of it that way. Now there is also, let me see if it's here. Yeah, you don't have it on the survey module. In the civil module, you have the civil module has a couple of routines called stockpile volumes and pond volumes, but all they are it's doing the exact same thing. It's just it sort of hides the process a little bit. You just basically tell it what layer the boundary is on, and it goes through and it builds all that stuff internally and doesn't save the layers. But since we know what's going on with this, we can do that fairly quickly and easily. So we need to now build a second surface that's called the stockpile base, or SP base, whatever you want to call it. And we can do that right from here. We go back to our triangulate and contour, and we're going to change now the select for our file. And we're going to call this one SP-base. If I can get my mouse to behave. And we'll leave everything else set as it is. We'll say, okay, we'll now select the inclusion, no exclusion. And now the data to get, I don't have to worry about weeding all this stuff out because this is a 3D polyline. All I need to do is select that polyline, and that's it. Done with that. I now have a base. And there it is. And there you can see again, we should probably build, you know, a series of edge to edge lines so we don't have all of these little skinny triangles going across. But you see, it's, even though the triangle's there, it's not terribly out of the realm of that being what's really, you know, what it really looks like. So we'll leave it at that without worrying about fine tuning that bit. So now to compute the volume, I'll simply go to my surface menu and choose volume by triangulation. Choose two triangulation surface volumes. I'm going to start up here at the top. I'm going to see where it says select existing surface. That's my base. And then it says now select the final surface. That's my stockpile. I choose open. And I could choose even a different inclusion polyline. Maybe I only want to look at something within a particular area. But I can say, I can pick this again, or I can just say enter, because it will stop at the edge of those surfaces which were built with those already. So it doesn't matter. I'll just hit enter, and put in shrink and swell factors. You can report tonnage if you know For instance, maybe this is a coal stockpile that's 80 pounds per cubic foot. And say, okay, here now comes your volume. And this should be almost entirely fill. It's not exactly, because there's a little turned up corner over here on the edge of the perimeter that sort of gives it a little bit. You can see it's got 2.7 cubic yards of cut because of that little flip up. Okay, but just it's almost all fill. So I would call that, 88,500 cubic or 3285, 3275, 3250, however many cubic yards, or say 3,500 tons of coal I've got in my stockpile. And a couple of things here that this report gives us is, if this were a design issue and I'm trying to balance my cut and fill, or maybe I'm looking at a particular, like I designed a borrow pit or something, or putting in a building pad, and I want to make sure it's balanced. Well, I can look at this and it says, well, if you change the elevation of that final surface by, in this case, 3.5 feet, lower it 3.5 feet, it should match. The cut and fill should balance out to be 0 in each case, or close to. So if I took that one surface and dropped it 3.5 feet, now that would be sticking down below, partially below the base. But when I compared the two, it would show me to go from one to the other, I would have an equal amount of cut and fill. Okay, and then this line here tells you how much it will change for every 1/10 of a foot that you go up or down, on average. Okay. So that's, I still have this little stray point out here somewhere.
Can you go back to how you made the surface of just the toe there? I missed that.
Yeah, sure. If I can get, there we go. So to make the surface that's just the toe itself, and let's look at it here. Turn the triangles off. And let's add the stockpile to it. Come back to this. Now, the only reason I'm putting it back in here is just to show you that, one, there's the stockpile. There's your little flip up area that didn't get, that's why you got that little bit of cut. So if I spin this up and around and I see down underneath, there's my base. And if I go over to here and toggle on the stockpile, you can see how it sits on top of that base. All right, so that's the question, is how did I build this base? Okay, so remember, when you triangulate and contour with Carlson, what you are modeling, you're building a set of triangles based on the data that you select when you build the surface. So if I want to build a surface that goes from this edge over here across to this edge over here, or all the way back and forth across, then I need data that shows me what those elevations are. And because I drew that line as a 3D polyline, now that may be what you might have missed. I erased my original 2D polyline and I redrew it as a 3D polyline. And I went from 0.2000 to 2028, and then I did C to close. So I now have a 3D polyline, which we will verify here. So you see how that line walks through all those points all the way around it, okay? So the way I did that was because this was 3D, I didn't have to select everything and try to get rid of these points in here or freeze them. I could have frozen this group of points and just selected that data. But the only thing I needed is enough to form triangles. So when I triangulate and contour, and I'll do this one again, I'm still looking at my base. Use my inclusion exclusion. That's going to be that 3D line around the edge. And I'll densify it to every 5 feet. Or I could even undensify it to get a little different. And now I select the inclusion. There are no further inclusions. There are no exclusions. And now select the points and break lines to triangulate. I don't want to window everything. I only want to select that. And I'm done. I hit enter. So now when I look at that base, now I see because I turned off the densification function. So that's why that you don't see all those thousands of little triangles across there. And even though, again, even though you see some triangles, you don't really you know, it's still relatively flat is what I'm getting at. Now here's again some data issues that, you know, is this maybe a bad point, or, you know, it starts here and it comes all the way down here and then climbs back up. So, you know, or maybe this point up here in the corner, see how it flips up? That's why you wind up getting that cut and fill condition, because these triangles simply formed differently. And you could also even maybe consider putting that line out here, which would be this line across from here to here, but I would not do that because I have a point here that says it is the toe. So the toe doesn't actually go out to here. It does stop right here. So it really does do that inset. Okay. So now you've got those two surfaces. I've got the base. And got the stockpile on top, and I wish it wouldn't do this, but you have to do it to reset it. And then that's how you can compare those two. Let me turn this contours off. Now you can see the two different surfaces. Or you can even toggle stockpile on and off. Okay. Maybe give it some exaggeration. Okay, so what I hope that you'll remember from all of this kind of manipulation is how to use this 3D viewer, how to use that to your advantage and to evaluate what you're looking at, what you're doing. Okay. Now, do you guys let me see another example that I might want to step you through. Let me take a look at this, for instance. If we see, here's where we did exactly that. We drew back the toe points based on the groups. So that's all in there as well. There's computing the volume that shows you how you do that. There's two named surfaces. And then it goes on a little further to design a pad. Let's say we were looking for a borrow pit. So this example continues on some more design effort, which you guys as surveyors probably wouldn't necessarily do a lot of that kind of stuff. Or do you ever? You ever do, design of graded areas? Yay, nay, not much, a lot.
No, not typically.
Okay, so I'm not going to force you through those examples, but it's there for you for some further learning if you'd like. And it even goes into, we merge those two surfaces together, and how you can draw the contours of each surface independently. And then we drew a little center line here for an access road. Took a profile of, there's the existing ground. We then created over here this road profile with parabolic curves, and then made a little surface out of the road, tied it into the stockpile edges, and then merged it in, and there's the resulting contours. So that access road comes in and lands down here in the stockpile, and that was rendered with a gravel pattern or something. It's just a visual enhancement. So that would represent a potential access road up to, you're on the stockpile, and that would be a required borrow pit, the depth and the size that you need to make it if you had a particular amount of material that you needed to recover from that stockpile. Okay, so I'll let you step through those. At your own leisure. Now there's another one. I don't. I'm just looking at my thumbnails here. I don't know that it's included in this, probably not. But it's a real good example of using field to finish on the fly to help you generate something. Yeah, it's not in here. But let's do that part next real quickly. And if I'm going to make sure you have the file, that's the first thing. If I go to open, see what we've got. We've got civil, class example 1, Water Oaks. Here we go, F2F on the fly. We'll come back and revisit this when we get the field to finish, but let's go ahead and set it up and look at what we have. If we open a file called F2F on the fly, then zoom extents, okay, there's nothing in it. So let's go to the points menu and set a coordinate file. And let's see if we can find. Yeah, it should be called mantopo. Mantopo.crd. We'll open that. We look at our list points. Make sure we have them all. There they are. So I've got a bunch of points. I've got a point code 17. And I've got these codes from field to finish. And begin and ground shot. It says, so I've got 17s and 18s, but let's right now just simply draw, locate points, and let's draw all. Well, hopefully yours didn't sit there and spin its wheels. See down in the lower right, it's still in the process of drawing points. I don't know why. it's taking such a long time. I think I know. I'll check it here in a minute. Almost there. Okay. So there's a bunch of points that are red. We've got a bunch of ground shots up here. A bunch of points around the edges, 17s and 18s. I tell you, I know why it did that. It was on my point defaults. No, I thought it was using field to finish. To set the points. I don't know why. Misplaced a symbol here. Let's see something. It's all right. It's misaligning some of those. Did yours do that same thing? I'm betting not. I'm betting yours drew just fine. But over here is the actual point. And you see that's a separated point apart from the symbol. See how that symbol got shifted? Anybody else has wound up shifted like that? Let me get rid of everything. It's done. False. All right, so I'm drawing nodes, annotated. Points. Select the symbol, there's no symbol. Look at it, we'll see. Descriptions, elevations. It's not using a GIS file and it's not using field to finish as a code table. So that part's all well and good. CRDB file, I'm wondering. Did anybody, somebody tell me when you drew your points, did you get any of those shifted symbols?
Mine came in fine.
All right, I'm wondering if there's anything to do with know you opened the same file.
I'm not seeing the points. I linked the CRD file, but if you want to start from the top, that might be helpful.
Do a zoom extents. If you did a draw locate points, do a zoom extents and you should see them.
Yeah, I tried that a couple different times.
Okay. All right, so first thing to do, if you haven't already, is set your coordinate file to mantopo.crd. That's manual topo. And then list your points. Go to points menu and choose list points and make sure you have $356 total points, or 343. There's some gaps in there.
Okay, yeah, I can see them when I look at the list.
Okay, so you got them in a list. Now go to your points menu and choose draw locate points. And then down at the bottom, just simply choose draw all.
Oh, cool. That did it. Thank you.
Yeah, did anybody else's take a long time like mine? Or did yours come right in?
Mine took a while.
Okay. Anybody else's, was it slow like this?
Yeah, mine took a little while.
That should not be. I don't know why that's happening. That should be done by now a long time ago. I was really concerned about what might be causing that. And I want, it could be that annotative switch. Or I wonder if, because I've said I want to use the CRDB format, and I opened a CRD file, that shouldn't have any problem either. But see, I've got these points like this one here. You can see that point is right there. But the symbol got placed over here. See where it points to that symbol. So it knows where the point is, but it drew the symbol in the wrong spot. And here's a case where, you know, this point didn't draw a symbol at all. And there's something, and yours are okay, that worked correctly. So they came in just fine, right?
Yes.
All right, try something here. Carlson. All right, so everything's out of that. If I say set the coordinate file, 0.2 and topo. It's still. Did everybody's take a little time like that, or did it all come in? I mean, did it come in quickly?
Mine came in quickly.
All right, those who said it came in quickly, what version are you using?
19.
19. So this is doing it in both IntelliCAD and AutoCAD. Now I've got my annotated scaling turned on for this, but my blocks worked out correctly in this version. So the symbols all came up correctly. Whew. I do not know what would have caused that, because it should come right in. Let's try this for a minute. One last shot. I'm going to turn my annotative scaling off. Select everything. Points. Nope, it's still taking the sweet time. All right. Well, we'll make that another mystery to unravel. Back to this real quickly. Two versions, I don't know. All right, there we go. All right, so we have some points, some pretend the symbols worked. But here's a way you can use that if you, again, if you knew the way these things were set up. And if I build a surface out of that, we're going to select and just call this one a we'll call it field. I'm not going to use inclusion, exclusion. I'll let it shrink wrap for me. I'm going to turn on draw contours and say okay. Select my data, and there it is. And you can see, well, it looks okay out here in the middle of the field, but look at this mess in here. And if I look at that in my surface viewer, see all that? Because I've got some obvious points, and I know that this is a field with a ditch around the outside edge of it. Okay. So what we're missing, obviously, are that define those edges. I need those break lines. So I'm going to raise my contours now. There's my inclusion, exclusion, shrink wrap. I should have said none. But that's okay. We'll leave it at that. We'll take that away. So what I've got are a series of these points, and I've got this point number 130 is a 17, 131 is a 17 code, 18 and 18 and 17. So it looks like if we were to create our 3D lines, from the set, connect all the 17s up, connect all the 18s up. I can make sure I get that right. So, and then I may have missed, I did miss that one. So anyway, if I were to look at my viewer, well, that looks to me like what could be the top, the top and the bottom edges of a ditch. That's what I'm after. Have any of that stuff drawn. I can go through drawing all that if I wish, or an alternate when we're doing this, and we'll come back and fine tune this tomorrow during the field to finish work. But when we notice that 17s are all top of bank, top of slope, 18s are all bottom of slope. So we could create a real simple field to finish code table. So we draw field to finish, and we're going to come down here where it says our code table, and we're going to say set, and we'll just call this one field. It'll be a new one. Now I don't want to import the code table, or I could either just go straight to it, or I'm going to import, I'm going to make the code table from the points. So that's my first option right there, code table by points. And now I'm going to look at my code and edit my codes. And I see I've got 17s, 18s, and ground. So I'll edit each of those, making sure the grounds are points only. That's fine. 17s, I want 3D and 2D polyline. I don't really need 2D. I'll just go 3D polylines. And 18s are going to be 3D polylines. Okay. I'll save that. I'll exit, and I'll now say OK. And now it's going to draw. I should have limited my redraw. Sorry about that.
What did you use for a menu to get there?
The survey menu, and I chose draw field to finish. And I hit the set button to the right of the code table. And as soon as this comes back, okay, there it is. So now if I triangulate that, and again, we're going to revisit this. Let me go to my triangulate tab. I'm going to change that reduction to no reduction just to get the thing out of there. Yep, it's okay to overwrite. There's all my data. It's now a 3D polyline. And now look at the contours. Well, that's a little bit better what I was looking for. And if I even take a look at the viewer and then add my field surface, turn off my triangles. So now you can see those contours go up to the edge, walk down the side of the ditch, go across the bottom, and work my way around my field. So very quickly, I was able to just make a temporary field to finish file and tell it to draw some 3D lines and then generate that surface. And there you can see it. Again, let's make it a little more reasonable. There's 1 foot contours. And you can see as they go through the ditches. And there may be some little glitches up in here that you'd have to straighten out. But the point is that it was able to read those codes just based on, hey, there's my codes. I've got a bunch of points. I don't want to have to play connect the dots. My codes looked like they were going to be in order. Everything worked out great. So that's useful for things like if you get a bunch of survey shots in, they all say, you know, CL for centerline or EOP for edge of pavement, and nobody connected those up as 3D polylines. You can either, you know, take the time and effort to draw 2D or 3D polylines through all those points, or you could simply go in there and set a new field to finish file, let it read the code, look at your code, make sure it's setting a 3D polyline as a break line. And now when you come back and model your data, you've got it in a much better shape. If you recall that jumbled mess on these edges, now we have nice ditches, okay? Now I really have to wonder, all right, so that's basically the same thing. All right. So, so that's an example of how you can use those tools to help you evaluate very quickly. You're looking at, you know, some stuff you could, you know, make point groups and freeze off those other groups and take a look at how those line up and see if they're going to give you that advantage. Now, because you guys work for a surveying company, and yes, I know we're 15 minutes over, I'm going to track that as well for you. So how you can use that to your advantage, even though because you work for a surveying company, a surveying firm, and some of you folks are spending most of your time in the field anyway, so you're already bringing in those break lines with your field data. Hopefully you are, or if you're not, by the time you're done with this training, you'll know to do so. Then that's going to make the modeling process that much faster. So when it comes in, it automatically draws that stuff, bing, bang, boom, you're done, you've built your surface, hand this to the engineers and go on to the next job. So, you know, hopefully you can all see that advantage. Hopefully you're not like, I mean, not hopefully, obviously you're not like, but I've got some surveying companies that refuse to look at field to finish. They say, we can do this just by click, 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 click. We don't really want to get into the complexities of field to finish, and it's really not that hard. And a lot of times it's just ownership of the company not trusting in the intelligence levels of these field people, which is a shame because they're the ones out there on the ground, getting shot at and doing the work. They know what they're doing. They know how to do this. All you got to do is show them where the tools are. So congrats to all you guys for that. And we'll see that in a bit more depth when we look at the field to finish part, either tomorrow or Thursday, by the time we get to that section. And in the meantime, I will be looking at those codes. Tom, if you're still on and you're hearing me, I'm going to take a look at your code table and your examples and see if there's anything I can spot that might either be tweaked or maybe just get an understanding of how you guys are using it. And then there's some good reference material that's in your data sets that we'll talk about when we get to it. So with that, any questions? Everybody good? All right, I will, if I get the movies to process today, I will get the link sent back up. You should have all gotten that one for yesterday's. I will get today's up there when it gets finished processing, because it takes a couple of hours to go through the YouTube works. But again, if not, at the end of all of this, you'll get a repeat email with all the links. So we'll be in good shape with that. Okay. Let's see, here's a chat. Okay, Sally, yes, I will do that to help you with that as well. All right, so the rest of you guys, if you're done, you may go ahead and leave the session. If you'd like to stay, I'm going to work with Sally here to finish up this stockpile and to see why something's going on that's a problem. So maybe it's something you can learn. If you'd like, you're welcome. If not, you're also free to go. Okay.
All right. Have a nice night, everybody. Thanks.
You bet. See you guys in the morning, those who are leaving.
Thanks, Ken.
Night, everybody.
All right, I'm going to stop my share. And I'm going to go ahead and let it stay recording so that you can, maybe it's something somebody can work with. We're back on the stockpile, right? Or
Well,
are you on this?
I
one?
went forward and my code table's empty.
Okay, so this is actually not the stockpile. This is just an open field. That's why I was
Yeah,
wondering.
the one before it, I can't find my stockpile tin file before we went this far.
Okay, that's all right. Let me do remote control. Okay, now couple of things I see here. You've got two versions of sample from T3. I think they're probably stored in different locations.
Probably. Yeah, I don't.
Which is okay. Part of that could be from
I was trying that earlier and screwed up and just went forward.
oh,
That's okay.
All right. All right. And part of that could be from I'm going to say that could be from, if you guys are set, your configuration should be set to these project data folders. So you're using this project folder setup where things go into these particular built surface or folder structure. And that's okay. Yeah. You just have to know where this data is going.
I have no clue.
Yes. So what we're going to do is I'm going to select these lines. I just drew those in earlier to illustrate what we could do if we had to draw them by hand, point by point. So
before all this, if I do a undo can we get back to that stockpile? Or does that matter?
Oh, you want to do the stockpile? How did this one go for you here?
My code table's missing,
Okay.
so I couldn't
All
get
right,
to my view.
let's wrap this one up real quickly.
Yeah, okay. Yep.
And let me get rid of these items. All right, so what I did with that draw field to finish, we noticed that we have a code 18 and a code 17. And then we got all these ground shot codes. So I go like 17 to 18 to 18 to 17. And if I look at that, I'm gonna draw that in 3D. I won't prompt. I'm just gonna grab the points. Let's just do from here to here to here to here. All right, now I'm in plan view with that, but if you look at this stuff, oh, let me fix something for you there. Selection and a display. Yeah, that gets in the way. So let's turn that bit off. You still have annotated objects. What's this? Oh, it's a wipeout. All right. So if you look at this, even though in plan view, it looks like a jagged line, if we look at that in 3D, you're going to see the points. Where did my line go? What was that? Says it's a 3D polyline. Yeah, see, I should be seeing that line. It may be, no, it wasn't due to that. Yeah, that's kind of what I should be looking at. I don't understand though why. All right, so that is elevation 0 all the way around. That's why it's all at 0 elevation. There could be something going on with this. If I draw a 3D polyline, and if I don't prompt, it takes 17, but not 17, but 130 to 125 to 82 to 39. Let's see. It's 14, 4, 4. All right, so that worked that time. And do that, my viewer. Yeah, there we go. That's more what I'm looking for. So anyway, I can tell that that sort of defines. Let me just turn that box back on. See, that sort of defines the edges of that ditch like I would think it would be. Now, that's not, I'm not going to draw that line as a break line. The break lines are going to go through those points, but basically perpendicular to that line. I'm still a little confused about something here. If I turn my point object snap on, draw a 3D polyline, no prompting. Wow.
It wasn't me.
No, it's not you.
They called me loose cannon quite a few years ago, if that gives you any idea about me.
See, as I scroll through this set of vertices, it's all 0 elevations.
Well, when I couldn't find the stockpile, you went forward and I tried to do it again. And then by the time
That may be,
I got done, you had gone to this point where the ground shot showed up. And so I did that and it worked. But
that's okay. I'm confused though why there's something that's causing that not to draw. It's a 3D polyline. I don't. See, there's no reason if I turn this on and then do it from, see, it's reading that elevation as 0. That's not the case. Your dialog box, does that show an elevation with a value in it like 763?
I'll get it.
Yeah, see, that has the elevation. I wonder, I think I may know what's going on with this. This is, no, it is sitting at the right elevation. If I select those and look at my viewer, I thought maybe that the points were drawn at 0, but see there, they're where they're expected to be. About the
I might have missed something back before this.
no. There's something not behaving. Settings. Don't want your software window now. Set that to 05 for you. Better. See, point object snapping is on. It's what I want to do. If I draw a 2D polyline, if I point to here, see it snaps to that point location. So it's reading the XY correctly. Now this is just a 2D. elevation 0, that's as I expect. Now, if I draw a 3D polyline, I should be able to simply say, okay, hover there, and it reads that, but you see down here,
Yeah.
the Z0. And there's no reason for that. We've got two items. Block one's a point. The points is at 773. The point is, the block reference is at 773. Bring that across to the other screen. There we go. All right. That. One more time, drag that over for me.
I don't see it.
For your grouping. Wow. I'm gonna look at my screen here for a quick minute. Yeah, see, it's working just fine. So you're having to actually type point numbers. All right, if I try this. Oops. No. That's obviously an issue. Do you have anything else? Set. Let me turn node off. Nope. That still reads it as 0. Take a look at this one more time in the viewer. And let's unignore 0. See, it's picking up something down at 0.
This happened earlier when you were looking for something, when everything was all red, early this morning.
Yeah, sort of like that. Let me, oh, over here's your stockpile, by the way.
Oh, I was wondering where it was because I can't find the tin, TIN file.
Well, the 10. Surface file viewer, this would be wherever your data is. Data
The
set,
stockpile. Yeah, the stockpile.
that's,
It didn't create it when I typed it
Oh.
in, but it says that it's there and I can't find it.
what do you mean
Um,
it says that it's there? What do you mean?
When we went to Surface, um,
I see 3.
right there. It should be there,
Yeah, it should
but
be.
when,
Oh, it's only this EGT only. That
yeah,
was,
but when we were up at this Surface,
oh,
it's
That-
it was here earlier.
that doesn't mean it exists. Well, that's field. And when you had stockpile, now that doesn't mean that it made it. That means that's the name it was going to use.
Oh,
So it may have messed something up with that.
so I created that red 3D line.
Yeah, and see, that is
Um,
poly,
and then
and it's at
I-
the right, oh, no, it's not at the right elevation. Let me see. Yeah, it is. Yeah, I thought I read a 0 in there a minute ago. That's okay. Yeah, so that one created itself correctly. Now, when you did that, how did you do that? You typed in 2000 to 2028?
I think I did all.
No, I mean, when you drew this line,
I don't know.
3D poly, did you type
I
in?
went, no, I went 3,
Yeah.
Hmm.
Now, at that point, did you type in the point numbers?
no. I used, remember when we saved
You did.
and
You-
excluded the
you
B
did.
toe and the B?
You did a shrink wrap. I can see
Okay,
because
okay,
that you missed a point right here.
okay.
So if you,
Huh.
so you could add
Yeah,
vertex up to here. Now that should be elevation 395.33 if that snapping worked correctly. And it,
how do you tell?
it says 397.18. Okay, so it kept it at that elevation. So I can't seem to get the edit or the spin to work. All right, so if I want to change this, I want to put it at the insert of this block. That's a 396. Yeah, it should not be 397.18. That's this point. Should be 395.33. So there's something restricting Surely it will snap to node. Wow, this is really perplexing.
Can you pick both and then move that?
Well, yeah, see, you should be able to. You know, I should be able to just simply grip edit that and snap it right into that. But that's trying to find an in point.
Yeah.
See, 395.33, that should be what that is. Now I tried to grip edit that and move it. Or I should be able to snap to node. It finds it, but it won't change that. Well, yeah.
Is that gonna mess it up if we can't do that?
No, but I mean, I wouldn't want you to do any production work. Now there's point 2018, that elevation needs to be 395.33. See, I got,
Yeah.
but I'm having to, I'm not able to snap and read the elevations. Why not? You don't have a
Well-
point filter on. These are just temporary trackers anyway.
So I went back to page 40 and did the triangulate and contours and set those tabs in the label tab and did an okay, and I couldn't get that surface to.
Now you've got, let's take a look at what we have here. In view. See, we still got this. See, your line fine, but there's still something down below. So all that's good. So that's everything in the drawing. So I'm going to erase everything outside this. Right, erase all, but remove this. Go back to that front facing view, erase all, but remove this. So it says nothing else is in the way. Now, that is bizarre. keeps reading an elevation of 0. Doesn't matter if I snap to node or snap to the insert. When I look at that 3D polyline and cycle through the vertices, the elevations are all 0. Well, there's something that's causing your snapping. Let's turn that snap off. And individually, node snap. See, it's still 0.
So even if we created that stockpile TIN file, it wouldn't work correctly.
Yours should be fine. If I look at this again now in my 3D. See, I still don't know what on earth is going on with this. This has got to be a setting.
It was in the other drawing as well, so
Yeah,
I don't know.
it would be in any drawing.
Hmm.
I open. Let's do F2F complete. Let's look at that one. We'll view that stuff. See, ignore zeros. Even when I ignore 0, there's something really bizarre going on here. And if I drew a 3D polyline, yeah, see, it's snapping to the horizontal geometry, but you see down here where it keeps telling me it's 0.
Mhm.
That should not be happening. Because these things, if you look at that over here in this, see, it has an elevation. 503, this one will be 505.
Yeah.
Oh, wow. Sally, I don't have a clue. There is something about the configuration. Let me see. One last place to check.
I wonder if Tom knows, because it's not just me that was having that issue.
That's what I'm wondering, but it may be something he's not aware of too. I mean, I've used AutoCAD since it's been a product since 1982, or even before that. Yeah, 80,
Yeah.
81, 82. And I've never had this occur. So it's a setting somewhere, but it could be an error condition that is set somewhere. So I don't know. I show in my 3D crosshairs.
What's the command at the bottom above OK? Show the Z field for pointer input. What's that?
This is the Z-axis by the crosshairs for it. That's 3D crosshairs. I don't need that in this 2D. And this is for your I'll show you what that is. When that's on, you have to have your dynamic input on, which is
Yeah,
dynamic input. And it would be this mode here. So now if I do a 3D polygon, and if well, I can't use the Carlson command with that. Let me see. If I now go to, see, that's my dynamic input. Let me know where to stretch it to.
well, don't worry about showing me that.
Well, I think that may be the root of what's causing these problems. If standard. See, here's what that checkbox does. You see these 3 fields?
Yep.
That's asking for the elevation. See if I set a point filter of see, it still reads that as a 0. There's something. Doesn't matter. I'm going to turn off that dynamic input for you. All right, we've got the grips are off. This hyperacceleration is on. That's okay. So that's not. Let's see here. UCS is world. See, even if I say an AutoCAD 3D polyline, and if I snap to the node of that point, if I look at that grip as an elevation of 0, see my vertex, it's 0 and 0. Bear with me a quick second. Snap. Object snaps. I could disable the delta Z by default. I think I may have found it. All right. It's a system elevation, a system variable called elevation. If you want to use object snapping to avoid the Z content, you set O snap Z to 1. So this may be at O snap. Oops. O snap Z. Ah, that right there fixed it. You do a 3D polyline now. And I go from here. See the elevation down there?
Yeah.
To here. So the elevations are now being read. I look at those, cycle through them, 397.46, and I'm looking over here, so that's 397.74 and 396.52. Wow, I had no idea about that as an object. You may have just saved the day for the folks at your company.
Well, good. Write that down. You can tell everybody. 'Cause- So tomorrow when we come in, is there a drawing I can start at and then I can go over this part with Tom at another time? Because he'll be coming up to work with me some Friday.
Or I would just simply ask him if he's aware of that, and I would not, I'm gonna leave it like it is now so that you can, as you work, as you follow along with what we're doing, that you can, you know, you won't wind up missing any of that stuff. Now, when I look at this stuff now in my viewer, let's see if I fixed that. Ah, look at that. Where'd it go, Sally?
Oh, good. I'm glad you found it. My
Boy,
frustration wasn't for
learn something
nothing.
every day. I've been using AutoCAD, like I said, for 40 years. And I've never run into that. Now, it's intentional. It's there for people who don't want to work in 3D so that they don't accidentally snap and inherit an elevation that they didn't mean to. And that may be why Tom has it set. But I've never worked that way. I've always worked in 3D. And I've always wanted those elevations. Wow.
Okay.
Bet that's
Huh.
exactly what's going on with these other computers that this happened to. And they're not aware that that is set. Wow, wow, wow. Okay. So I will let you all right, so now to build this surface real quick, let's just step through this real quick. We need to build two surfaces here, one at the base and one at the stockpile. So if we go to surface, where's the menu? There it is, triangle. Yeah.
Because I set all these to page 40 and 41, where it was supposed to be.
Page 40 and 41, you mean in the book?
Yeah,
What do we?
and somehow I was supposed to create that stockpile file.
Well, that's what I'm getting ready to do right here. So we're going to create, I'm going to turn the contours off right now so that we don't have a bunch of stuff showing in our way. So let's build the base first. We're going to type that as stockpile base. Write the file, select stockpile base. Okay. Ignore zeros. We'll densify. maybe 5 feet, just for yucks. We'll say, okay. Now here's our inclusion. No more inclusions, no exclusions. And the only thing we want to use is this 3D polyline. Okay. So now when we view, there's our stockpile base.
Okay.
And,
I don't know where the yellow comes from, but
well, that comes from,
yeah, you went through that before.
yeah, that comes from,
I guess I didn't save it.
no, it doesn't let you. There we go. Set the color. So that should be okay.
You had it as 13, but that's okay. Green is good.
But I mean, why is it yellow? Let's try to draw this. Color by elevation. Oh, wow. Those colors. All right. Now let's tone this down a bit. There we go. Now we're looking at it like we need to see it.
Okay, that's where I
So there's our base.
couldn't make it work.
That's all right. There's our base. And let's repeat that. And this time call this one stockpile. We'll take the inclusion, no further inclusions, no exclusions. And this time we'll grab everything, which includes the points in the middle. Okay. Now I've got a couple of vertical edges. It's within tolerance. I'm going to just say exit. I will verify that. There's my stockpile. And there you can see. And as you look up underneath, you see there's nothing under that one. If we look at model, we can add the stockpile base. And now you can see it. Okay.
Okay, sure.
So now you've got those built and you could proceed with doing that field to finish on the fly exercise. But we'll look at that when we get to the field to finish part. But it's basically just a matter, well,
That's okay. We can do it later. Maybe at lunch tomorrow or something.
yeah, we'll because let's see, what is there? Now we've got these, let me see, if you've got the points still in from man topo. Yeah, it looks like we've got them.
Okay.
Yeah, okay. So let's do that part real quick. I can show you.
And then I have some boys to go home to, so.
So if you were to draw those points then. All right, so there they are. And without the break lines for the top and bottom of the bank. Okay.
Okay.
So, yeah, it's still recovering a little bit. So if we go to draw field to finish, and it says my code table is empty. This one you called file, that's fine. So let's go to edit codes, or we could have imported codes, but let's see. Let's create down here this code table by points. And according to field code definitions, create a new one. Field, just so we have it something different. symbol. Let's see, SPT. 9, that's right. All right, so that's built now. I've got 17, 18, and ground. Those are the only 3 codes that we have. I'm going to edit 17 and make sure it draws a 3D polyline. I'll edit 18 and make sure it draws a 3D polyline. And I'll save the code table. I'll exit that. And it should be processing this morning. End coding special code set to caret. Try this one more time real quick. Draw field to finish. Field. FLD, additional draw options. I'm gonna leave a Z on, not off. Line work off, actually by code. So that there. Okay. Edit my codes. The code table settings. Special codes. Again, I'll set that back in a minute. There it is.
Why is this different?
Well, it was trying to process the code that it couldn't find, so it's now got the codes. The codes are set to work correctly. And now, when we look at that in our 3D viewer, everything's nice, exactly where we expect it to be. We line up here, we look, yeah, we see a ditch. We do a quick profile by screen entities. Go ahead and build the surface yet. I'm going to look, say going across from here to here. And lo and behold, that's exactly what I expect.
Okay.
I don't have an adjust. You don't see an adjust button, do you?
No.
It's interesting. Screen entities. Okay. Well, maybe you have to have a surface file to do that. I bet that's the case. All right. So anyway, you see that you verified all of that. And now you just do the same type of thing under triangulate contour. And now I'll turn the contours back on. So you can see that all happen at once. But where it says write to triangulation file, right now it's back, it's still pointing to stockpile. So I'm going to select this and I'm going to call it field. And I will, no need to densify that one. I'll say, okay, I will, oh, I will uncheck use inclusion and
Yeah, okay.
set my shrink wrap reduction to none. I'll just select all these objects. Off it goes, contours of
Okay.
build. And
I did that part.
you did that part, but you didn't save the file perhaps. Okay, so
Probably, yeah. I
Yeah.
thought I did. It was lowercase, but
yeah, now here's that same, that yellow looking
yeah.
surface. So I'm going to toggle that on and off. I'm just going to reset these down a little darker.
It's okay.
Yeah, so anyway, just play with those as you need. But as you can see, you've got a really nice, well-defined surface there. And both literally and metaphorically, that will hold water. Because you've got a ditch that'll hold the water. So
Okay.
I'm going to zoom extent so you see you've got both of these exercises in here. Now, you
Okay.
have the points over here that came out of the stockpile coordinate file. But then we changed it to a new coordinate file and set to man topo. Okay, so,
Yes.
so right now, if we wanted to, you could set your coordinate file and go back to that, whatever it was, example 1. I think it was. Let's see. Oh, you don't get a preview over here. Here it is up here. Now they've changed that around in the new version. So that has 80 points, goes from 2000 to 2079. Those are your stockpile points. So if you option those and list those. Remember the B toe and the B. Okay.
Yeah. Yeah.
So the points I have available in the CRD file, but I still don't have all the points in the drawing.
Okay.
So just keep track of that and always look up here at the top and you can see which one's active. And you can set
Okay.
it back and forth. You could even merge one into the other one, but it doesn't make any sense to take these points, 10 miles over here out of the way. So there's
Okay.
that. We'll save that. We're going to let you go so that you can get home, see the boys.
Well, thank you, Ken. And I'm glad you found out an issue that
Yeah,
you
me too. Well, thanks
had.
for sticking with me.
I won't remember what it is, but you can.
Well, I sure will. And it's something to really to bring
Go
to
over with Tom.
Now, Tom may be fully aware of it and it might be intentional. If that's the case, it's something he needs to let you folks know about. If
Okay.
if it's not, it's just something that was accidentally set by somebody at some point. It
Yeah.
could be a button or a command that caused it. So that's the way it
You
works.
can.
All right.